Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi and welcome to GeeksforGeeks. So without any further ado, let me put into the stream Yash as well as Abhinav.
Hi Siddharth, how are you?
Yeah, I'm fine. So hi Abhinav, how are you?
Yeah, hi everyone. I'm fine.
So Abhinav, I think Yash is not visible to me. Is Yash visible to you,
Uh,
Abhinav?
yeah, he's visible.
Okay,
Yes, Siddharth.
fair enough. Okay, so today we would be solving the SD sheet again, and the topic for today would be linked list. We would be covering the two pointers also. We would be covering everything from that would be required. Okay, so yeah, so let me just Yash, can you please share your screen and show
Yeah,
how to
sure, I'll
access
share.
the SD sheet?
Am I not visible? I think. Let me
The
just.
quality is quite low. I
Yeah,
cannot
yeah,
see
yeah.
everything.
Just
Yeah.
okay. Yash, can you rejoin?
Okay, I'll try to rejoin.
Okay, quickly. Okay. Hi Abhinav, can you quickly introduce yourself?
Yeah, sure, Siddharth. So, hi everyone. I am Abhinav Avasthi. I am currently a DSA mentor at Geeks for Geeks. I'm a five-star coder at CodeChef and an expert at Code Forces. So,
Okay, that was great. Yash, can we have a quick introduction about
Uh,
you?
yes, just facing some. I think I'm still facing some network issues.
Okay,
But
so till
hi.
then, yeah, you can
But
go ahead.
just let me just give me a second. I'll change.
Okay, sure. So, hi everyone. Let me quickly introduce myself.
Now,
I'm
if am I
Siddhartha
visible?
Hazra.
Let me know.
No, you're not visible for me. Abhinav, Yash is visible
yeah,
for
no,
you.
no,
Okay.
he is not visible.
Okay, let's see.
Am I visible now, Siddharth?
No, you're not visible. No, Yash. Hi everyone. Hi. Please schedule next time by 6 p.m. I think the weekend we should enjoy the weekend the whole day and then we should come home and then we should start from 9 p.m. Okay, because you can have your dinner while you are watching and by the time you sleep at around 1 the stream would end. So according to the feedback given by you, sir, we would we would be covering today link list. Today link list would be
Yeah.
covered. So yeah, we would be just starting off. Okay, fair enough. No, Yash doesn't look like okay.
Uh,
Fair enough. Hi,
now,
Yash. Yeah,
now am I
absolutely
visible?
visible.
Okay,
Yeah,
so there was
absolutely
some
visible.
network issues. So
Yeah,
hi
it's okay.
everyone, my name is Yash Dwivedi. For a quick introduction, my name is Yash Dwivedi. I'm currently working as a mentor at GeeksforGeeks, and I'm a candidate master on CodeChef and a 5-star on CodeChef. So let's quickly start with the series. What do you think, Siddharth?
Yeah, absolutely. Can you just show how to access the SD sheet? Can you quickly share your
Uh,
screen?
yeah, I'll share my screen. Just give me a second. So is my screen visible now?
Just let me see. It's loading at the moment. Yeah, it's visible
Yeah,
now. Yeah, you can
yeah,
start
it's
off.
visible.
Okay. So again, today we'll be doing the linked list. In the previous session, we did arrays. Now today we'll be doing linked list, and from where we are picking up these questions. So basically, we are picking up these questions from the GFG SD sheet. So there are two ways that you can access the GFG SD sheet. So let me just first of all quickly introduce you about the GFG SD sheet. So if you just Google that this thing, that is GFG SD sheet, then the first link that you will get is geeksforgeeks.org link. So here you will be observing that there are various questions. Like you can see the topic arrays is there. You will get the editorial for it. You will get the practice link for the question. Like you can see here we have the leaders in array question. So if I click on it, so I'll get the link for solving it. And I'll also get the video for it. Can you tell us a little bit more about this video thing, Siddharth?
Yeah. So this editorial is given by some industry experts as well as from the mentors of Geeks for Geeks. So, okay, so
Yes.
in this, you would be explained the approach as well as, okay, Yash is not visible on YouTube streaming, okay? So just let
Am
me
I not visible?
confirm. Yash, look, I would confirm you don't do anything, please. Okay, just let me check.
It's
For me, Yash is visible. Let me see. Okay, actually, the thing is, people are seeing it lagged after 20
Uh,
seconds. Okay,
I
yeah,
think
your
I'm
name
visible
visible
now.
now. Yeah,
Okay.
yeah, yeah. It's
yeah,
So
yeah.
okay. So basically, the videos are made by the industry experts. Okay, like you can see, Soham Mukherjee is there, so he's currently working in Google. So there are various questions in this SD sheet, 186 questions to be specific, and for all the questions, we have the video editorials made for them, and all the video editorials are made by industry expert. There are a lot of video editorials that are still under process, so they'll be made one by one. Okay. So this is one way of accessing the sheet. Is this clear to you, Siddharth, as well?
yeah, it's clear for me. Abhinav, is it clear for you?
But
Yeah, it's clear.
Okay,
okay,
yeah.
now let's say that if someone wants to practice the sheet, then what we can do is we can go to Geeks for Geeks practice, and when you click on the GFG practice portal, then you will see here that there is a problem section. Now in this section, you have the SD sheet already tick marked. So SD sheet is already selected here. So there are total of 186 questions in this sheet that is highly curated, and it is based upon the frequency and the concepts, and that has been built by the team. Now if I see here, so if I click on the linked list part, so now in this sheet what happens, the SD sheet is there, and in this I have selected the topic linked list. So you can see a total of 19 questions are there. So in this 4 hour stream, what we will try to do is we will try to cover as many questions as possible, and we'll be starting with me only. So is this clear to everyone? All of you can tell me.
Yeah, it's absolutely
Siddharth,
Yeah,
clear.
is
it
this
is
clear?
clear. Yeah, yes, it's clear.
Absolutely.
So
Okay,
all of you
so
can give us
before,
yes, yes, Siddharth, you can continue.
yeah, so yeah, everyone is clear with this. So what you can do is people are asking. So there are beginners also. So can you quickly tell everyone what is linked list? Like, what do you mean by linked
Uh,
list? Quickly, or should I do it
so
if you want?
Siddharth, I think you can do it.
Okay, absolutely, not an issue. Just let me do it. Okay, let me share my screen. Okay, fair enough. So a linked list. So the first thing that you remember in linked list is it is a set of nodes, or you can say it is a set of spacing that is not in a same position. Like suppose we have, and let's talk about the array. Okay, let's talk about array first because I think the people who are here to learn linked list already knows about array. Okay, suppose this is the array and this is the first index, this is the second index, this is the third index, this is the fourth index, and this is the fifth index. Now let's do the indexing also. This is 1 0 1 2 3 4 and 5. So suppose the address to this is 505, then the address to this would be 506. Okay, and yes, the integers and all do take up some space. I'm not digging into the, but what I want to convey is that the spacing or they are in consecutive nature in the memory. Okay, but let's talk about the linked list. Linked list is the same thing. Okay, like these all arrays only, but they are of this form, like this and this and this. Okay, and the memory of this, suppose this is 505, then this won't be 506, and this is not consecutive. It is just kept here and there in memory. So why do
Correct.
we have this? The first thing is that they are connected via links. Okay, via links. If there is only one link over there, it is known as singly linked list. Okay, am I clear enough?
Yeah, absolutely.
Okay, so now we know about doubly linked list. What is doubly linked list? Doubly linked list is nothing but two linked list. Okay, so before moving forward with doubly linked list and then circular linked list, let me first tell you one major thing that would be used in all over the question. So the questions specific to linked list has a very special property that you need to keep in mind. That special property is that the indexing is not there. Please remember it that the indexing is not there. So if you are at this node, then you can only walk to this node. And if I am currently at this node, then I can't go back to the previous node. There is nothing like that. I can only go to the next node because that is the only link that is given. Let's talk about the doubly linked list. In doubly linked list, things are quite easy to be honest. Why? Because we can just traverse here and there. Like from a particular point, we can just go here and there. We can do that. Now there is one more term that is known as circular linked list. Circular linked list is nothing but as the circular array, the last node would be connected with the very first node. This is known as circular linked list. So now the main problems that we would be discussing is involves majorly of single linked list. So make sure you understand single linked list and you keep in mind this property that I can only move forward and the indexing is not present. Can I have a quick
Okay. Okay.
yeah? Can I have a quick
Siddharth,
yes or no from the people?
as you said that
Hmm?
indexing is not present in linked list. So how can we
Hmm.
traverse through it? Means how we can just traverse through the elements of the linked list and,
Okay,
for example, we have to find a
so
sum.
let's talk about a very simple problem. Okay, let's talk about a very simple problem. Suppose we have 3, then it is pointing to 4, then it is pointing to 5, then it is pointing to 6, then it is pointing to 7. Let's take a very simple example. So in most of the question you would be given the reference to the very first number, and that would be referred as head, and this would be referred as tail. Tail and all won't be required, but I'm just telling you if the mentors use it. Okay. And there is one more thing to remember. After this point, see, 3 is pointing to 4, 4 is pointing to 5, 5 is pointing to 6, and 6 is pointing to 7. But 7 would point to something known as a null pointer. Okay. This is a null. Okay, so we can take use of this property. How we can take use of this property? I will just tell you. Okay, yeah, so I can take use of this property. Yeah, so I can take use of this property by using a simple condition. See, 3 for 3, the next is not null. For 4, the next is not null. For 5, the next is not null. For 7, the next is not null. So what I can do is I can begin with the head and I can simply use a while loop and I can say while the head is not equal to the null thing, and we can keep moving forward. We can keep moving forward by using head is equals to head dash next itself. So in the first iteration, head is not equal to null. So we would move forward. Head is not equal to null, we would move forward. Head is not equal to null, we would move forward. Head is not equal to null, we would move forward. And at this point of time, head would be pointing to null. And at this point, we can just stop. See, at this point, head is equal to null. So this condition is broken. So this for loop, while loop won't be executed. That is why I can say that yes, we can traverse in the linked list by using this while loop, which is the most simple one, as well as you can use a for loop too. But I think that implementation is a little bit big. So while loop is simple to understand. So Abhinav, is your doubt clear?
Yeah, now it's clear. Thanks, Siddharth.
Okay, fair enough. So
Okay.
any more further queries or any more further prerequisite you need, please quickly tell us so that we can just move forward with this. Everyone quickly just tell us that any more prerequisite you wanna know. Any simple prerequisite. Yash and Abhinav, you can quickly suggest the prerequisite according to your wish.
Yeah. Just want to tell that using this technique while we are traversing to a linked list, we can do multiple operations. Like we can find the sum, we can find the length of the linked list. These all the operations can be done using this single method only. That we can just go till our head will become null. Okay. So there are
Yeah,
multiple applications how we can use this method now. Yeah.
yeah. So what we can do is, so Yash, you can just open the question, and I will just finish off, and you can start. Okay. So what you
Yeah,
can do
sure.
is the most simple thing that you can do is that you can initialize a counter to 0, and then as you see a not null node, you can keep incrementing. Okay. So hope I'm clear. So Yash, open your question, and I will add it to the
Uh,
stream.
Okay, sure. So,
Open the question.
starting off with the questions. So first of all, we'll be starting off with a very basic question, that is reversing a linked list. Okay. And by the way, Siddharth has also told us a lot about linked list, and Abhinav has also told us. But I'll be covering a little bit more details. And some people also mentioned that will we cover this thing in Java or will we cover this in C++? So while I'll be writing the code, I'll be telling you a little bit differences in terms of memory also. Like if you have to delete a particular node in a linked list in C++, if you want to delete that node memory, so in that case you will be using the delete keyword, right, Siddharth? And if you want to do it in Java, then you will not do that, because the garbage collector thing is already there in Java. So there you do not require the delete thing specifically. Correct, Siddharth? Have you seen these cases?
Yeah, absolutely. I've seen this cases, but very little.
Okay.
Okay, so
Basically, this is the difference.
just before moving forward with this question thing and the problem set, what are there are some rules that we would be using this. So at currently there are more than 115 people. So what I want to convey is when mentor would be explaining the question, he won't be answering to the comments that is getting there. After he has finished the question in one flow, after that we would address the doubts. Okay, and most of the doubts would be resolved in the comment section only. And some things like out of the box, you are just talking in general. Okay, like यहाँ पे मस्ती मजाक भी होता है. We do fun because for a duration of 4 hours, it is not possible that we would keep our concentration very high at this point of time on a weekend. So it's fine. You can make general queries, you can laugh, you can have fun, but do it within the limits. And the queries would be answered after question is done explaining. That's it. Yes, yes, you can move forward with this.
Okay, so first of all, let's start off. So as Siddharth has told, so suppose Siddharth that I have a linked list. So Siddharth has told us that we have always have a node in a linked list, correct? So let's say that if I make this particular linked list, okay. So like see, every linked list can have various things in a particular node. Okay, let's say this is a node. Let's say this is a node. So there are various things that I can have in a node. Siddharth, have you ever seen this concept? Like, have you ever seen a concept of a class? Like, have you ever used classes a
Yeah,
little bit?
yeah,
Possibly, yes. Right. So in
yes.
classes, there are various entities, right? There are various data types. Like similar to class, there is also one more thing in C plus, like in C plus plus and C, that is known as struct. Have you seen it, Siddharth?
Yeah, absolutely. I do. I use it more than the
Yeah.
class.
Correct. So basically, there is class and there is struct. So in Java, mostly they use classes. So basically, what you can do is you can have various entities inside it. Like in this linked list, since I want to be a singly linked list, so what are the two entities that I'll be having? First entity that I'll be having will be the data. Okay. First entity will be the data. And what will be the second entity? Can you tell me, Siddharth, if I want to
That
make it
would
a
be the
singly linked list?
pointer. I think that would be a
Yeah, that will
connection.
be the
So
pointer.
basically,
Yeah, that
yeah,
would be the pointer that will store the address of the next node, right? So that is
yeah,
how we
absolutely.
make it. Okay. Now, if this suppose this was a doubly linked list, in that case, what would have happened? Like this would have been there, and now in this middle one, I would have stored, let's say, the data, right? This would have stored the address of the previous guy. This node would have stored the address of the next guy. Then I would have another node. Then I will have the data here, suppose, right? And the this node will store the like this thing will store the address of the previous, and this will store the address of the next node, right? So that is how things work in a doubly linked list, and that is how things works in a singly linked list. But now why this was important, because we'll be using this thing more frequently. Now let's say if we have a linked list like this, suppose, okay. So if I have a linked list, let's say basically this is the data and this is the address of the next node. So suppose I have a linked list like this. Suppose that the linked list looks like this. Suppose the linked list has data 1, okay, then 2, then it is pointing to, let's say, 3, okay, and suppose this is pointing to 4. Suppose this is already given to us, right? So we'll be given the head of the linked list, as Siddharth earlier said. We'll be given this particular head, and suppose we are pointing to 4. Okay. So now my question to you is, like, how do we actually normally see that? So as Siddharth says, that we represent it like this: one is connected to 2, 2 is connected to 3, 3 is connected to 4, right? This kind of thing. This is how we represent a linked list in general. But if I ask someone that, okay, suppose this is the normal linked list that we have, and how can I traverse it? Like how can I access it or access the elements, or how can I traverse it? So I can traverse it using the head of the linked list, correct? So if suppose that someone will ask me to Siddharth, can you tell me what will lie here? Like for the last node, what will lie in this pointer?
So it would be the null pointer.
Null, correct, because there is no further node. Now, if we have been given a linked list like this, suppose 1 is connected to 2, okay? From 1, we are going to 2, then from 2, we have the node 3, then after 3, we have the node 4, okay? Now, if I ask you to reverse this particular linked list, Siddharth, so if I want to reverse this linked list, so basically what does that mean? If I'm reversing this, so what does reversal mean, Siddharth? Can you tell me when you think about reversal, so what comes to your mind?
So we are more accustomed to array. So in array, what we can do is
Okay,
we can
suppose
just,
suppose we have an array. Suppose we had
yeah,
1, we had 2, we had 3, and we had 4. Now this is a normal
okay.
array. Now if I ask you to reverse this array, what does that mean to you?
So what I can think of is I would take one more data structure and I would start putting up the elements like one would be, then two, then three, and then four. So I can do like this, and then I can say that yes, this is the reverse tag, and I can just
So
copy
basically,
down. Yeah.
you are
So
saying
I'll
this
just
thing.
copy down. Yeah, I can do this thing. Okay.
Okay,
And
so
there is
this
one
is
more
what.
thing that I can do.
Okay,
So if we don't want any auxiliary space, what we can do is we can have an access to the first and the last, and we can keep swapping that. But this thing is not available in the linked list. Why? Because I can't have this thing. So if I do the swapping, I need to also take care of the pointers also. Like if I'm
so
just
you are saying
pointing to
that
the
you will
head
take
and
a
the tail.
left pointer and you will take a right pointer. Okay.
Yeah, for the array. But how it is to be done for the linked list? Can you explain us? Yes.
Okay. Now, as Siddharth has said, that we do not have access to the last element of the linked list. Why? Because we are just given the head of the linked list and we do not know the rest of the elements. Rest of the elements we can traverse one by moving our head or current pointer. So how do we reverse a linked list, right? Now, what do we want as the reverse linked list? Siddharth, can you tell us that? What do we want? Like, do we want something like this 4, 3, then 2, and then 1? What do you think?
Yeah, absolutely. We want this kind
We
of
want
structure.
something like this. Okay, so we want something like this. So in this case, what is happening? If you see, we will want something like this, similar to the array. We want this 4, 3, 2, and 1. Now the pointers are getting. If you will see, what is the difference between this representation and this representation, Siddharth? Can you highlight us? Highlight it for
See,
us.
I can see that four has an incoming node. Okay, over there in the original linked list. But in the
Okay,
next
so what I
resultant
will
one,
do is
I can
I'll
see
write
that
it like
four.
this. Okay.
Yeah, yeah. So yes, on the original one, I can see that four has an incoming node from three. But here in the resultant array, as in the resultant linked list, I can see that four has an outgoing link towards it.
So basically, you are saying that indirectly it is written like this only, but the pointer is changing. Only the
Yeah,
direction of the pointer is changing.
yeah,
Correct.
absolutely. Yeah,
And here the 4 was point like 4, after 4 there was nothing. So after 4 the next pointer was null. Okay. And here what is happening after 1, the next pointer must be null. This is what you are saying.
yeah.
Correct. Okay. So now let's see how we can reverse a particular linked list. So everyone can tell me in the comments how we can do this. I know this is very basic. So what we can do here is, suppose we have one. Okay. After that, like let's first of all draw the original linked list. Suppose we have one. One is connected to, let's say, two. Let's say two is connected to three. Let's say after that three is connected to four, and after that four you have a null. Okay. Now Siddharth, in the final answer, what do you want? You want a linked list like this. You want 1, 2, 3, 4 only, and you want the pointers to change. So what do you want exactly? Can you tell us that? Can I say this, that suppose if I talk about two particular nodes at a time, two nodes, two adjacent nodes at a time. So let's say if I take 2 and 3, Abhinav. Okay, suppose that I take 2 and 3. So in this case, what is the difference that you can see between 2 and 3? Can you tell me that?
So I can see that the pointer, or you can see that the next pointer, which is currently the pointer at 2 is pointed towards 3, and the pointer of 3 is pointed towards 4. That thing is reversed basically. Means now 3 is
uh,
pointed towards 2. So that's the difference I
okay,
can
so
see now.
So instead of this connection, I am having this kind of connection. Correct. That is what you are saying.
Yeah, exactly, exactly.
Okay. So if I try to generalize this thing, can I say that suppose 3 is my current node? Suppose. So in that case, 2 will be the previous node. Correct.
Okay,
Correct.
okay,
So in that case, can I say that I want 3's next, I want 3's next to point to 2? Can I say that? At
sure.
least this thing, can I
Yeah,
say that? Definitely I can say
yeah, we
that.
can.
Okay,
Yeah,
we can say that. Fine. But we can say that for every current node, we want it to points to it to point to its previous. That is fine. But now also tell me this thing, that what about this node? What about the node 1? What about this node? What about this node 1? Should it also point to somebody in the reverse fashion? Like, should it also point to somebody? Yes, it is pointing to null. Correct? Correct, Abhinav?
yeah, 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 exactly.
So, so in this case, what intuition comes to your mind? Like anything? Okay, I'll tell you. See, what you can
I
do
was
here
just
is,
thinking now, yes, that because what we are doing that we are pointing our current to the previous one. So if we will start our current with the head pointer, and we want our head to be pointed towards null, na, in the reverse linked list. So
suppose
yeah,
we are
this is our
starting our
current.
current from here. Okay.
Yeah,
Mm-hmm.
and we want the current to point towards null in our final linked list, which is a reverse linked list. So we can take a null as a previous node and we can just point towards that. Is it possible?
So you are saying that you will take your previous here, like you will take your previous as
As
null.
null. Yeah. And then I will just make our
Okay.
current point towards previous.
Okay. So let me do this on the original linked list. Okay. So suppose this is the
Yeah.
current, right? So
Fine.
current will be basically marked as head. I will mark the current as head. Okay. And then what I can do here is I can say that, okay, I'll have a previous which will be initialized to null. Okay. Now what are you saying, Abhinav?
Yeah. So I was just saying that what we can do now, that we can point our current pointer towards the previous pointer. Because that is what we
Okay.
want in our final linked list now.
So you are saying that for the current, the second guy that it is like this pointer that it is pointing to 2. So
Hmm.
you are saying that what you will try to do is you will instead of one pointing to 2, instead of one's next being 2, you will try to change it. You will try to say that, okay, one should now point to the previous. Like one's next
Yeah.
should be the
Well,
previous. Correct?
yeah, that
Okay.
is what I
Now
was just thinking.
suppose Abhinav that you do this thing, then this connection is lost.
Okay. Okay. Yeah. That's the thing. So
So in that
to
case, I lose
store
the
that
access of the
thing,
rest of the linked list. Then
yeah, that's the case which I missed. So we can take another pointer that just take the case of that linked list, which is basically the next of current. So we can take a next pointer too,
correct.
that will store the rest of the linked list. Now,
Because what is happening here is if one was pointing to 2, if one was pointing to, like, if one's next was 2, then now
yeah,
I am saying that one's next would be the won't be the previous guy, that is nothing but the null here. So in that case,
yeah,
what happens,
yeah,
this connection is lost, and if this
yeah,
connection is lost, then I will lose the access to the rest of the linked list. Correct. Which is something that I
yeah,
don't want. So in that
exactly,
case, what we can do
exactly.
here is before reversing, we can say that in a particular variable, let's say I name it as any, or you can name it as next or something. So in this variable, I will store what? Like I will say that, like initially we will say that, okay, previous is equal to null, first of all, right? Then we'll say that, okay, current is equal to head. All right. After this, we will be doing some steps. So what will you do? Like you are saying that first of all, Abhinav, you will have a node, like you will have a node, correct? You will have a node next in which you will be storing this particular node. So with what is this node, how can I access it? It will be nothing but current dot next, like that is
Current
nothing
dot
but
next.
current next,
Yeah,
right?
yeah.
In Java you can write it as current dot next, but this will be current next. Okay. Now you tell me this thing, Abhinav. Let's say if I have stored it, now what is your like what will be your approach further?
So now what I will do now, that first of all I will make our current to point towards the previous one. So means
So
let's say
you are
that our
saying that,
currently our current is one, our next is two, and our previous is null. Okay. Now what we'll do, that we will make our current to null. Fine.
so you are saying that your current can now point to the previous. Current's next can now
Yeah.
point to the previous. Current's next is equal to
Yeah.
previous. Okay.
And
So in this case,
then
what
we'll
will
update
happen? Current
values.
next
Hmm.
current next will become the previous. Okay, fine. Now if this thing is done, right? So if this thing is done, then what is happening? This guy is pointing to its previous, like this guy is pointing to its previous, so one is pointing to its previous. So this much,
Yeah,
like one reversal has been done, one reversal of relationship has been done. Now,
has been, yeah.
Abhinav, my question to you is now which, what do you think? Which are the next nodes that for which you want to change the relationship?
Okay, so now what we want is that now in the place of our next, we want a current now. So we can make it like our current is
So
equal to next. Can we do
So
that?
can I say that? Can I say that I want one and two? I want to choose one and two, and I want two to point to one. Like I want two's next to become one.
Yeah,
Can I
yeah,
say this?
that is what we want. Yeah, yeah.
So if I want this thing, so in this case, how can I update? Like if I am doing this thing, if I'm doing this thing along with the current, like current and the previous variable, help me to change the pointers. So Abhinav, in this case, what will you do? You will simply say that
Mm,
now the previous should come to this one, because what is happening? Two is pointing to one, right? Two's next is nothing but one. So in this case, what is happening? Like the previous, like the current that was one, now it should be the previous, right? One should become the previous because earlier this was the current. Now this should become the previous node, and current should move to the next node, correct? Current should move here, correct?
yeah, yeah,
So in this case, what will happen? Previous will be what? Like previous will be nothing but the current node. And what will be the current node? Current node will be nothing but the next node, correct? That is what I'm trying to do here. Now once I have done this thing, so what happens if I do this thing? So after this, the pointers change. And now will you reverse? Like now will you change the relationship? Yes. Because what you will do is like, Abhinav, will you do this thing directly? No. Now what will happen? First of all, the next will be stored,
yeah,
correct?
yeah. That, yeah.
Now the next is stored. After this, what happens? After this, the current next will point to the previous. So 2 points to this one, and then this connection is lost. After this, what will you do? After this, you will simply say that again you will repeat the cycle. Again you will say that okay, now the current will become the previous and the next will become the current. Now again what happens? Now 3 starts pointing to 2, correct? Then again before that, again before that, what you would have done is you would have said that okay, then the next will be this guy. Then what you will do is you will say that okay, 3's next is now 2, and then this connection will be lost. After this, what will you do? Again, here this current will be now the current, now 3 will become the previous and 4 will become the current. So again what
Yeah.
happens? Again you store the next node. So this is the next node, correct Abhinav? Now null with the null
Yeah.
will be the next node, and then
Yeah.
4 starts pointing to this 4 starts pointing to 4's next will become nothing but the previous node, that is nothing but 3. Okay, so then what happens? This connection is lost. After that, I'll again update my previous and the current. So what happens
Okay.
now? Now 4 becomes the previous node, Siddharth. So 4 will
Yeah,
become the
absolutely.
previous node. Then what will happen? My current node will become null. So Siddharth, what do you
Okay.
think? What is the stopping condition?
So the
Like should I
stopping
do more
condition,
reversals?
no, more reversal is not needed. So what I can do is when I would point to the very last node, it would be the stopping condition.
Correct. So whenever the current is equal to null, that is the case when I'll stop. So what is the case when I'll be iterating? So if the current is not equal to null, till that point I'll keep on iterating inside the linked list. So can I say
Okay.
that I'm doing a particular process repeatedly, like again and again?
Yeah. Yeah,
So
absolutely.
can I say
Because
that
when
I
it is
can
not
can
null,
I
we
say
are performing the same condition.
so can I say
Yeah.
that we can use a loop for that? Correct. So this is the
Yeah, we can use a
initialization
loop.
part. What I've done is initially previous is pointing to null, current is pointing to the
Okay.
head. Then what we are doing is we are saying that while the current is not equal to null, till that point of time we'll be iterating. While the current is not equal to null, till that point we'll be iterating. And this is what we'll be doing. We'll be first of all storing the next node. Then current's next will point to the previous. Previous will be the current and current will be the next. So again, this process will keep on repeating. So is this clear to everyone in the audience as well?
Yeah, it's
Running the
clear.
loop.
So while we are just waiting, so let me just sum up what Yash is saying. So the basically question wants us to reverse the whole linked list. So now let's talk about the reversing of a linked list. So in the reversing of a linked list, we observe that we don't want the linked list to be reversed Rather, the elements can remain at the same position, and we can only talk about by reversing the condition, the connections. Like if we have 1, 2, 3, 4, then we can just reverse the condition, and now 4 would be pointing to 3, 3 would be pointing to 2. I can do this thing. So now, how would we reverse this thing? So now we would take the very first one and we would say that yes, this would be the last one, and this would point to null. But see, we would lose the very first node. That is why we would save the very first node somewhere, and then we would start
Correct.
reversing the links itself. And then, as we are reversing the links in the same manner, so instead of doing it one by one, we can move forward and we can use a loop for that. Because it might be a scenario that in this example, the number of nodes are quite feasible to individually reverse it. But in the scenario, when the number of nodes are very huge, that it is given that the length can be anything, we can say that yes, we need to use a loop that would automatically do the all the job on itself. Yes, am I clear? Did I sum
Yes,
it
you are
up
clear.
correctly?
Yes, correct. So let's
Okay, yeah,
quickly
you can
write
move
the
to the
code.
coding part. Yeah,
So I
just
hope that your
increase the
screen is
font.
perfectly visible.
Yeah,
Okay,
just
I'll do
increase
that.
the font. And just
Is
one
it
more
visible
thing
now?
that, yeah, absolutely visible. Yeah, you can move forward with the implementation.
You were saying something else as well?
No, 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 it's absolutely fine. Move forward.
Okay. So see what I'll be doing. First of all, Siddharth, can I say that I need a previous, like for storing the previous notes, I need a previous, correct?
Yeah,
And initially, what do I want for the previous? I want the previous to be null because for the starting node, I want it to point to null. So that's why the previous
yeah,
initially will be nothing but null. Okay. Then what I want is I want also the current node. So I want the current is equal to the head node. Correct. This is a
yeah,
good practice to do in like what like Siddharth, we could have also taken the head, right? We could have also moved the head in this case. If you will see here, instead
yeah.
of current, since we have the head, so we could have also moved the head. But what is the
We can move the
what
head
is
and
the
we can keep the head.
but what is the disadvantage of that approach if I take the head?
So see,
So in that case,
many a times in the online judges, in the functional programming thing, we need to return the head. This means that we need the address of the head at the end. So it's a good practice that we keep the head intact and we do all our operation on a copy of it. I hope
so
we are clear.
correct, correct. Because if you move the head here, then you move the head here, then after that you move the head here, then head moves to someone will ask me that okay, tell me the starting point of the linked list or traverse the linked list once again, then we'll not have the access to the head. So in that case, we'll be in trouble. So that's why it's a good practice to take a current or a variable instead of taking the head directly. Okay, then what I'll do here is I'll say that the terminating condition for me will be while the current is not equal to null till that point I'll keep on running. And what will I do, Siddharth? First of all, I need to store the next node, correct? Because
Yeah, absolutely.
I don't want to lose the access of it. So in that case, what
Yeah,
I'll say
because
here
we
is
would be
I'll
reversing the
say that
links.
yes. So first of all, if I'm reversing the link, as I said, I'll repeat this again. If I
Yeah,
have a linked list, if I have a linked list, let's say 1, 2, and 3, and I want 1 to point to its previous, that is 1 should be pointing to null, correct? If this is the current.
yeah,
So if I want once next to become null, in that case, this arrow will be lost, this connection will be lost, and then I lose the access to the rest of the linked list, which is something that I
yeah.
don't want. So before changing the
Okay.
connectivity, what I will do is I'll get the next will be nothing but the current dot next, right? Currents next. Once I get that, then what I will do is I'll simply say that now I can change the currents next to previous, and then this connection will be lost, and I'll be okay with that because now what I'll do is I'll say that okay, now the previous will be the current, and the next like the current node will become the next. Now again I'll do the same process here. So that is what we are trying to do it again and again. So first of all, I'll have the next node. So next will be currents next. Then what will I do, Siddharth?
Yeah, so what I
After
can do
getting the
is
next
now,
node,
so we
I'll say
already
that okay,
have the
currents next.
address saved. So now we would edit the link itself.
Yeah, so I'll change the connection. So that is now the currents next will be nothing but this. Just one second. Currents next will be what? Currents next will be nothing but the previous. Okay. Then after this is done, so I'll again update my previous. So previous will become nothing but the current. And what will the current? Current will become the next node. Correct. That is what I'll be doing here.
Okay.
Okay. And now
Yeah.
again, there's still one question, because the question require, like, if I want to access this linked list, right? So suppose that if I have reversed the linked list, right? Or if I'll go up, just give me a second. So if I'll go up, Siddharth, so suppose if
Yeah.
this is the linked list and I have reversed it, so now the linked list looks like what? Let me use a white color for it. So now I think that the linked list looks like this, right? Basically it is pointing to null. So this is how the linked list looks like. So it gets reversed now. But
Yeah.
Siddharth, I want the question is asking for the head of the linked list. So now what is the new head of the linked list? Can you tell us about that?
Yeah. So
Audience can
now the
also tell
new
us.
head. Okay, just let us
Next,
see quickly.
what is the new head of this linked list, guys? Correct. Vinod is writing correctly. What about this? New head.
Yeah,
Yeah, previous is the new
absolutely.
head. Absolutely true, because now the previous is standing at the new head. Okay, so this is very much clear to everybody as well. Great. So let's do this thing. So I can say that now the new head is what? New head is nothing but the previous node. And since I want to return the head, so I'll simply return this new head. Right. Now let's try and compile it quickly. Okay, so it works on the samples, I think, for 1, 2, 3, 4, 5, 6. Let's try and submit it as well.
Okay. Okay, so yes has already got an EC. Yeah.
So this gets accepted. So is this problem clear to everyone as well? Very simple approach for reversing a linked list. Can we just previous write? I am not clear what you said. Sanju, you can ask again. Okay.
Okay.
So let's move to the
So
next question as well. Yes, Siddharth, you
yeah,
can continue.
so we would just wait for the feedback that is being provided from the people. So the first feedback was that you can just wait a bit when others is talking and you can let the other people complete it. So can you quickly, okay, dry run is already done, I think, because by using the dry run, we wrote the pseudo code and then we moved forward and we wrote the code. So can you please tell us the time complexity? Yes, Yash, could you quickly move over the time complexity?
Okay. So what is the time complexity? The time complexity in this approach is nothing but order of n, because at most how many nodes we are traversing? We are at most traversing only n nodes, na, all the nodes that are present in this linked list. So that's why it's nothing but order of n only.
Okay, so can you
Is it
please
clear?
quickly tell us that how to get the time complexity through the code? Just quickly tell us,
Okay, through
like
through the code.
through the code.
Okay.
Yeah.
So in this case,
Suppose you
in
wrote
this case,
the
if
code.
okay, so in this case, if you will look at this code, if you will have a look at this code, so in this case, I am starting from where? I'm starting from the head of the linked list, right? And I am moving till when? I'm moving till the current is not equal to null. So basically, that means that basically, suppose that the linked list was 1, 2. Is this example visible, Siddharth? I hope that it is visible, right? If
Yeah, it's
suppose that the
absolutely
example is
visible.
1, 2, 3. So initially, my current will be at this node, okay? Then I'll do some reversal part. Then my current will be at 2. Then my current will move to 3. Then my current will move to 4. After that, my current will move to null as well, Siddharth. So after that, my
Yeah.
current will move to null. So how many nodes did I traverse in this whole part? I traversed n nodes, na? Total number of nodes that were
And
present, only that I traversed. So that's why the time complexity is order of n.
okay, yeah. So let me talk about it a little more. Okay, so we are just assigning the head and the pointer, and then we are moving forward. Okay, by just one iteration. So at each point of time for each of the nodes, we are doing constant operation. So for one node, if we are doing constant operations, then for n nodes, n being the size of the linked list, we are doing big O of n operation. Okay,
Okay,
and we are
Sanju is
not.
yes, Siddharth, you can complete.
Yeah. So talking about this space complexity, we can see that we are only using variables at this point of time, and it is fixed. So we can say that we are using constant space. Okay.
Okay.
So let's move forward to this. So will we have a resume session or not? Resume. The how many of you want a resume session? Can I have a quick heads up? And talking about Vanshika is wishing you hi. So
Hi.
let's Can you teach the run completely? Okay, quicksort is not within the range of this. Okay, Vidyashri. Okay, absolutely fine. So I think we can move forward, Gish.
Okay, one more thing, someone is asking, why did you not just reverse the previous? So if you want, you can just return the previous as well, because you want the you wanted to return the head, but I have written this thing so that it is much more clear that we are obviously we are returning the head in the end, and we are returning the new head. So if you want, you can directly return the previous as well. There is no issue with that also. Clear with this? Okay.
Yeah, sure.
Uh,
We can move forward to the next
so
one.
now let's move to another question, and let's see another question like this one. This is an interesting question, to be honest, and it has 2 lines of code in Java, but it has 4 lines of code in C++. Okay, so this is another interesting question. As I was saying initially, that the language difference you will observe here, like in Java, you have the garbage collection thing. In C++, you have to do it manually because you don't want any memory leakage. So this is one such question where you can observe this thing. Okay, so now what we'll be doing here is see delete without head pointer. So suppose Siddharth that if I tell you to delete a particular node in a linked list, right? First of all, let's come to a basic question, then I'll follow up with this question. So let's suppose if 1 is given, 2 is given, 3 is given, 4 is given, and suppose 5 is given, and suppose I give you this pointer or this particular node, I give you I give you the access to the head node of the linked list as well, and I ask you to delete this particular given node from the linked list, this particular node 3 from the linked list. So what will be
Can
your
can
approach
you open the,
indirectly?
so can you quickly open the problem page? Just one for once.
Yes,
Sorry to disturb. Delete without the head pointer. Yeah, you can move forward. Yeah.
if people want, I can share it in the chat. If you
No, no,
can, I
I'm
share
doing
it.
it. That's absolutely. Yeah,
Okay,
you can share it. Yeah, you can share it. Else I'm also doing it.
okay, I can share it. 1 second.
Yeah.
So I'll just share it. We'll be eventually moving to the medium level questions also, but we are keeping in mind that many beginners might be watching here as well. That is why we are taking some time. Okay, so now let's see this question. That is reverse, not sorry, this one, delete without a head pointer. So in this question, they will be asking you to delete the a particular node of a linked list without having the access to the head node. But in this case, suppose I first of all tell you that suppose I will give you the head, and I ask you, Siddharth, to delete this particular node which is 3. So how will you do this? If I give you the head of the linked list, then how will you do this? Then we'll discuss
So
how we
if
can do it without head.
if I am given the head and we need to delete at the PTR position, so what I can do is I would first go to the PTR position, okay, or before the PTR position, and then I
So
would
you're
try
saying that you will
to
stand
make
somewhere here.
two.
Okay.
Yeah, I would stand somewhere here and I would say two's next would be four. And then I would just skipping the three. I can do that. And by doing this, three would be removed.
So in this case, if this thing is done, right? So Siddharth is saying that this thing will be done, right? So in normally in Java, what will happen if this is the pointer, right? And you are saying that if you are given the access to the head, so you move from 1, you move to 2, then you see that okay, 2's next was nothing but 3. That was the node that you wanted to delete. So in that case, what you will say is that from the previous node, now previous next will be equal to the current dot next, right? So this is what will happen. So now 2 will point to 4. In that case, 2 will lose connection with 3, and this is what will happen. And in this case, normally in Java, what will happen, garbage collection kind of thing will happen. But if you want to delete in C++, then you will have to write a delete command, that is okay, delete this particular node, so delete the node, that is ptr. Is this part clear to you, Siddharth? When I give you the head of the linked list, is this clear? Can you hear me?
Sorry, sorry. Sorry, I was on mute.
Yeah.
Yeah, it's absolutely clear.
Okay. Correct. But Siddharth, what is the advantage here that we have? We have the advantage that we have the head of the linked list, correct? So since we have the head of the linked list, so we could afford to move through from the starting of the linked list to check what is the
Yeah.
previous node, correct? I could check that
Yeah,
okay, this
absolutely.
is the previous node. Now I can mark previous next as current next. That is what I can do, correct?
Correct. Yeah.
Because I was moving from the starting. But suppose Siddharth that I give you this thing where I like that is the same question that we are now going to discuss. So in this case, suppose Siddharth, what I do is I give you this pointer, okay,
Okay.
and in this case, if I ask you to delete the node, delete a particular node without having the access to the head pointer. So now how will you do it? Some people have written in the chat as well. So now if you have to delete this pointer without having the access to
Okay.
the head,
Okay.
there is one
So
more condition
what
that
can
is
I
given,
do?
but I'll come to it as well. Yes. Anything
Okay.
that comes to your mind?
So see, I want to go to 1 from 3. Okay. But I can't go in the reverse manner because this is not allowed in a single linked list. Okay. So what can be done? A hint from your side, Yash?
Okay, so the hint in this question is that you will you will be given note, like you will be given a particular note to delete that is nothing but indicated by DEL, or you can say it as PTR,
Okay.
but I will write it, I'll write it as DEL so that we are in sync with the code as well. So I'll write it as DEL. Okay, now I am giving you one hint that the node that I want to delete,
Yes.
it will not be the last node of the linked list. Yes.
Okay. Yes, what you can do is you can just have PTR because you were using this PTR and you can change it in the function itself.
Okay, okay, sure. I'll change it here.
Yeah, just
I'll
change it
change
in
it as
PTR.
PTR. Okay,
Yeah, and
perfect.
yeah, it will be
So
done.
perfect.
The hint is
Now let's say I'm saying that the notes that I like in this question, if you will read here, so they are saying that no reference is given to you. Okay, so it is guaranteed that a
okay.
node that has to be deleted is not the tail node. So it is not the last node of the linked list. It is one of the first n
Okay.
minus one nodes only. Okay, so
Okay. The
either
thing is,
either the PTR can be this node, either the PTR can be this node, either the PTR can be 3, either the PTR can be 4, but it will not be the last node. It will not be the tail node.
okay.
Okay,
So
so
I can
like
think
this is
of
a
as the
tricky question.
previous one. Yeah. Tell me.
This is a tricky question. Okay, so in this case, what you will do is, like, if you will observe, this question has been asked in a lot of companies. That is why we have taken this question as well. Some people are saying swapping and then deleting. Maybe
Yeah,
they are
you
also
don't
fine
need
in
to
their way.
kill it. Yeah. So you can just move forward.
Okay, okay. So see, you are here, right? You are here. Okay, now what you want to do is you want this node, like indirectly you want this to be deleted, but the actual truth is that if I'll not give you the head of the linked list now, then you cannot do this thing, you can never do this thing, correct? So that you cannot move back in a single linked list, correct?
Absolutely correct. So yes,
That
can
can
you
never be
pause
done.
for yes, can you pause for a sec? Because some people are not getting the question. So I would quickly sum up the question. So in this question, I already told that you don't have any indexing that is given. Most of the question you are given the head of the linked list. But in this question, there is a little bit of twist. The twist is that you would be given some random reference to any of the nodes and you need to delete the head of the linked list. This is what
Okay,
is there.
so I'll re-explain the question. Let's suppose that if I wanted to delete this particular node, if I give you a node PTR, let's say this PTR node is 3, and I ask you to delete it, and I also give you the head of the linked list. So guys, do you agree with me that it will be very easy for me to delete? Because in this case, what I can mark is I can mark the current from the starting, then I can mark a current here, then I can see that okay, the next node is nothing but the node that I want to delete. So in that case, what I will do is I'll say that okay, now this 2 can point to this 4. Okay, and then if it is Java, then I will not require to delete it. If it is C++, then I'll delete this node PTR using the delete function, right? Then what happens? This will get removed. So is this part clear? If I give you the head of the linked list, then how to delete it? Is this clear? If I give you the head of
Um,
the linked list, for those who
okay.
are clear, they can write a clear in the chat.
So yes,
For those,
let us just wait for a sec. Okay, let us just wait for a sec.
okay, many people are saying yes.
Okay, so let me just sum it up once in Hindi. Okay, so that people would understand. यहाँ पे we are given a linked list, okay, and a reference to the node that is to be deleted is already given, okay. Like we are given a linked list, we can't go backwards, we can only go forward, and जो delete करना है सिर्फ वही दिया गया है, वो head नहीं दिया गया है. So वो head से आके we would make 2.24. This is not possible. वो head है ही नहीं. यहाँ पे सिर्फ question में सिर्फ PTR given. वो head हमारे पास है ही नहीं. So how can we delete this? Yes,
Right,
you can move forward.
because what is the advantage when you are given the head of the linked list? When you are given the head, then you can have a current, you can move your current here, and then immediately you will see that okay, the next node for the current is the PTR node, right? That is what you wanted to delete. So in that case, what you will say is you'll say that okay, this guy 2 can now point to 4, and then you can simply delete this particular node. Okay, that is what you can do. But if I don't give you the head of the linked list, in that case, what happens? If you will observe, if the question says that you have to delete a particular PTR node, that you have to delete a particular node from the linked list without the head pointer. So when you're not given the head pointer. So in this case, suppose this is a particular linked list and you're just given the information about this PTR node, then how will you delete it? That is the question. Okay.
Yeah.
So now, actually, the thing is that you cannot directly delete it. Okay. It is actually almost impossible to delete it without having the head pointer. Because if you had the head pointer, then you would have pointed this to this. And then you would have deleted
Okay.
this node 3. If you don't have the head, then you cannot reach one by one till this 2, and you cannot make 2 point to 4. You cannot do that. That is actually not possible. Either you can stay here or you can move forward. Correct, Siddharth? That is the constraint with the singly linked list. Correct. So what will you do in this case? In this case, like, this is a tricky question, as I said. So what you can basically do is, if suppose this part is there, so in this case, what you will do is, if this node is having the value as 3, so I have the access to this node. Correct, Siddharth?
Yeah.
Okay. So what do I want in the final linked list? Can I say that I want the final linked list as 1, 2, and then 4 and 5? Kind of
4
this.
and then 5. Yeah.
Okay. Now you have to remember one thing for sure. You cannot delete this node, guys. Okay. Why you cannot delete this node? Actually, you cannot delete this node because you do not have this node. If you, because you do not, since you do not have the head, so you don't have access to this node too. If you don't have this access to this node too, then you cannot mark your 2 to, like, you cannot mark 2's next as 4. Otherwise, it would have been very easy. But if this is not given, then what we do here is we will simply say that we will copy the data of the next node. So what is the data of the next node, Siddharth?
4.
4. So what I will do here is I'll mark it as 4. Okay. Is it clear,
Okay.
Siddharth?
Absolutely.
What I've done
clear.
is mark this as 4. Now can you tell me now what can I do here? Now is this
we
something for
have
me?
now
Because
again.
looking at the final
Yeah,
answer,
it's a,
looking at the, yes.
yeah. So now it is given. Now the hints are getting aligned together. So now the hint that was given, that we are not given the last one.
I'll come. We
Now
will come to the hint as well. We will come to the hint as well. Why it is very important to understand
So
that.
now we can just copy the 5 at the 4th position.
But can you do, okay? So in that case also, like, you have to understand. Let's say Siddharth, let's say that I give you this thing. Suppose I give you a larger linked list so that your task gets a little bit more tedious. Okay, suppose I give you this thing, and suppose I give you this PTR. Okay, now if I want, so what is the ultimate answer that you will require? The answer that you require is nothing but 1, 2, then it will be 4, then it is 5, then it is 6, it is 7, then it is 8. Correct? That is what you will require.
Yeah.
Okay. So in this case, what I just said, like I said that what we can do here is, instead of this, like in this PTR node, what we can do is we can copy the next node. So now I am copying this 4, and now I'm asking you, Siddharth, again, how can you
So
do it?
now what I can do is, as this is getting longer, we don't have just 5. So now we can use the
I'm just giving you
conventional
one
method.
hint.
4
Okay, I'm
next
giving you
to
one
5.
hint. You just have to do one operation.
4 next to 5.
Okay, so you are saying that what you will do is you will mark this PTRs next to next, right? This thing.
Yeah, absolutely. I can do that.
Correct. That is what you will do. In that case, you will skip this guy. Is this part clear to everyone? That is how, and after that, in Java, if you have this node, right? So that means what will happen? This node will get deleted. Now, in this case, what will happen? When you have this particular node in Java, so it will automatically get collected by garbage. But in C++, you have to explicitly delete this node as well. Okay. So is this part clear to
Okay, sure.
everyone? Please tell us, guys.
I
Siddharth, is
think
that
it
clear
would
to
be
you?
clear. Yeah, absolutely.
Okay, so what? Okay, so what are you thinking, Siddharth, in that case? Like, how are you going to approach it?
So I would be
Like,
having the
can
PTR.
you?
So the main problem is that I'm not having the previous two. This is making all the difference. So what I can do is, I can just
You just have this
copy
node.
this. Yeah, so I can
So
just copy
first of
the
all, you will
next
see the
one to
PTR
this
data.
point. Yeah, I
So
can
you will
just
see
have
that
it.
PTR data is equal to the PTR next data.
Yeah, absolutely.
Wait a second. Like, how can I be sure that PTR next will always be available to me? Can you tell us?
Because of the hint. Because of the hint.
What is the hint here?
The condition is
Uh,
that it would not be the last one.
Guys, is this part clear to us? Clear to all of us?
Yeah.
How can I say that
So,
PTR will be always? How can I say that PTR will always be copying the data of the next node? I can say that because of the fact that the next node will always be available, because the PTR node will lie in the PTR node will always be the first n minus 1 nodes. So there will always be, in the worst case, in the worst scenario, if the PTR node is pointing to the second last node, so there will always be a last node, because PTR will never point to the last node. So that is the biggest hint in this question. Is it clear to you,
Okay.
Siddharth?
So I think everyone is clear with this. I don't receive a single doubt. So what you can do is you can move forward with the coding part. I think that
Okay.
would be
So,
with everyone's ground. Yeah, everyone is.
okay. So first of all,
And
let's
even just
quickly do this.
explain on the. Yeah,
Okay,
you can do
so
this.
PTR.
Absolutely.
First of all, I'll do PTR data. I'm just doing this so that nobody is confused about the dry run as well.
Yeah,
So
absolutely. Thanks
first
a
of all,
lot.
what I'll do is I'll update the PTR data with the next node's data. That is what I'll do. And how can I be sure that the PTR next is available? Because the PTR node that I want to delete, it will never be the tail node. So that means it will be one of the first n minus 1 nodes. So in that case, the last node, like the next node, will always be available. Okay. Now, once I have this thing, Siddharth, what do we want to do next? We want to say that this PTR should now point to this, correct? So what do you think? What should I
Okay.
say? Can I see that? Now the PTR next, right? PTR next should be equal to what?
That would PTR's next would be equal to the five.
PTR
That
next is,
is next one's next. Yeah. Next one's next.
okay, that is what you will do. But this code shall be written in Java only, right? Because if you write this in interview in C++, then you will be in trouble still. Because in Java, you will have a garbage collection. Okay, in Java you have something known as garbage collection. For those who know, they can write a +1 in the chat. For those who are from Java, they can write a +1. So in Java, what will happen? You will have a garbage collection, so this will automatically get collected, Siddharth. Okay, but
Okay.
in C++ we do not have anything, correct, Siddharth?
Yeah.
So in that case, this will be a memory leak, correct? Because you have allocated this thing a data and now it is lost. So in that case, what you will have to do is you have to explicitly delete this particular node. Is this clear, Siddharth?
Yeah, absolutely.
Okay, so first of all, I'll write the code for Java people quickly, then I'll come to
Okay.
C++ as well. Okay, so let's see. For those who also say that we do not write in Java, so we can write in Java. Okay, so in this case, what will we do? So as I said, we'll say that okay, okay, let's make it as PTR. The PTR node that we had, okay, the PTR node that we had here. What we'll do with the PTR node is we'll say that okay, PTR dot data is equal to what, Siddharth? Is equal to PTR dot
Is equals. Yeah.
next dot data, right? That is what we'll
Yeah.
do.
We will talk
And
about
then
this.
this is in Java, right? Because we have a garbage collection facility available in this language, but in C++ we'll be doing the delete part as well. And then what will I do? I'll simply say that I'll say that now PTR dot next is equal to what? Like if I want, what do I want? Now after this is copied, so what do I want, guys? I want the PTRs, I want this guys next to be pointing to what? The next dot next, now this guy, correct?
Yeah. Yeah.
Instead of this PTR pointing to 4, I want it to point to the next of next guy, right? So I want PTR next to be this guy. That is nothing but PTR dot next, correct? Is it clear, Siddharth?
Yeah. Absolutely. Yeah.
Okay, so that is what I'll be doing here. So in this case, I'll say that okay, PTR dot next. Is there any feedback from the audience up till now, Siddharth?
No, there is nothing. They are talking among themselves. We can move forward.
Okay, so let me just compile it. Then I'll come to the C++ code as well. Don't worry.
Okay, that's
Okay,
great.
work
People
on the
always
sample
ask
site.
for Java code too. And being a C++ coder, you are already also taking care of the Java coders too. Thanks a lot.
Because this concept is different, right? So you can see
Yeah.
here, like this gets accepted in Java. In Java, it gets accepted, but I'll write the code in C++ as well. Now in Java, what is the advantage? You had the garbage collection thing, but in C++, you don't have the garbage collection. So now I'll be covering the C++ and how you'll be proceeding further in C++ as well. So in this case, what we will be doing here is, let's say we are given the node, right? So Siddharth, let's quickly see that. So suppose I will unmark this again. Okay. So in this case, Siddharth, what are the changes that you will do? Let's quickly check that up. So in this case, what we are doing here is we are suppose I give you this as PTR, right? So in this case, first of all, what are the things that you think that we need to do? I want to
We all,
to copy this to 4, correct? That is one thing that I
yeah.
want.
that is done.
So
Then I
what
would
I
just
want is
move forward.
I want PTR data, right? I want the PTR data to be equal to what? The PTR next data, correct?
Okay.
That is one thing that I want for sure. Now, another thing is I want this PTR to now point to this 5, right? I want this kind of thing. I want that PTRs next should be equal to nothing but the PTR dot next, right? Because this is the for PTR, this is the next guy. Now this is the next dot next guy, right? So I want it to be pointing to the next, right? That is what I want. That is what I want. But Siddharth, in C++, we do not have garbage collection. So we have to explicitly delete it. Otherwise, we'll have a memory leak. So in this case, I want to delete this node. So first of all, how can I access this node, Siddharth? I can access it. Like, let's say I mark it as temp. So how can I access it? So I'll say that temp is equal to nothing but what? PTR next. Correct, Siddharth?
Absolutely.
If I am considering that currently I have not changed the relationship, so in this case, I will PTR next will be this guy, right? Then what I will do is I'll mark my temp here. Okay. After this, after I mark this as the temp, then I have stored it that okay, later on when I change this connection, right? When I change this connection, okay. So after this, I'll execute this command that okay, PTR next is equal to 5. So after it points to 5, then this connection is lost, correct? From PTR, now you are no longer pointing to this 4, correct? You are no longer pointing to this particular node. Okay, so now what is the command for deleting? So it is nothing but delete in C++. So you'll write delete and the temp node, right? So you'll delete this temp node. So now it will get deleted. So you will not have any memory leak in C++ also. Is it clear? In C or C++?
Okay, it's absolutely clear.
Okay. So what will I do here? Let's quickly check that out. So first of all, I'll have the PTR, okay, pointer that I have. So I'll say that, okay, pointer data that I'm having, pointer data that I'm having. First of all, I'll update it to what? I'll update to let's say pointer next data, right? That is what I'll be doing, pointer next, and then the data, right? After this, what I'll do is that I'll first of all store the next node in the temp, otherwise I'll lose it, na?
Yeah,
So
absolutely.
in this
We need
case,
to save
what
it.
I'll be doing here is, so I'll save it. So what do I want to save? I want to save the pointer, like I want to save the PTR next because I want to delete it later on. Okay. So that is what I'll be
Yeah.
doing here. Now, once I have saved it, so I'll say that, okay, PTR next for the current pointer, its next node will be nothing but the next of next. Okay. So that is what I am doing here. Next of next. Okay. Once this part is also done, right? So basically, once it points to next of next, then what happens? This particular node temp that is there, I want to delete it. So I'll directly write a delete command, then it will get deleted. It will get deleted. So in this case, delete command is there. You can see it is a keyword in C++. Then what I'll do is I'll delete the temp node. Okay, that is what I'll be doing here. Let's try and compile it. I hope that I have not done any mistakes. Just give me a second.
Yeah, it's absolutely.
Seems to work on the samples.
So,
Hopefully, it should get accepted as well. Yeah, it does work fine for this as well. So C++, everyone is clear in C++ as well? Yes, Siddharth, you can carry on.
yeah, so it's clear up till now. So we would be doing the resume review after this question. Till then, we would be just catering the terms. Okay. So is the intuition clear or not? Just let others, each one of
Okay.
us know.
Now, Tane is asking a question. Tane is asking that Tane is asking this thing that you are like Tane is asking that you are not deleting the next node and you are not deleting this PTR node. Okay, and that is what why I said that this is a tricky question. Uh, this is a tricky question basically because is my screen visible, Siddharth?
Yeah, it is.
It's visible. You can move
Okay,
forward.
okay,
It's
perfect.
visible.
So okay, so in this case, suppose this was the PTR given, right? If this was the PTR given and its next node was suppose 4. Okay, so in this case,
Okay.
you are saying the right thing, Tane, that you are deleting the next node, but basically they are expecting this answer from you. Okay, and you have to delete, like you have to delete the next node only because since if you had the head node, then you would have done this thing, right? You would have marked this thing, but since the head node is not available, so there is no chance that you can delete this particular node. Okay, so that is
Okay.
how this question works. It is a little bit tricky, but that is how you have to do this question. So can we move to the next question, guys?
Yeah, we can just move to the next question because I don't see any doubts coming in.
Yeah, that's
Okay.
clear, I think.
So let's.
Yeah.
Okay, great. So there's a question. Like I'm not sure. I'll be picking up another question. Like I have to maybe pick one more question before this question. But okay, let's pick this question. Let's pick this question.
Okay.
Maybe while I'll
So
be picking this question.
everyone,
Uh,
so everyone is suggesting that we should have a 2 minutes break. We can just talk in general. So I think we should make it an open forum for the next 2 or 5 minutes. You have been speaking for the last 1 hour.
Just don't want. I just
right.
want that
So
I
basically,
could do just
if you will
continuity.
observe,
Yeah. So if we talk about Yash would be happy teaching the whole day. Yeah, he can speak the whole day. It's absolutely fine with Yash. No, Yash?
Exactly.
Okay, fair enough.
okay.
Okay, so last time we were suggested
Uh,
some web series. Let us see that this time suggest us web series quickly. What was the last web series you watched? Delhi Crime was a good one. I saw it. Okay, so how many problems you have
Am I
left,
audible?
Yash? Yeah, you are perfectly audible.
So I'm still left with a bunch of problems. Like first of all, we'll be finding the middle first of all. Then after finding the middle, I'll quickly do it. Then we'll check the palindrome as well. And then after that, if audience will allow, then I have one more question for them.
Okay,
NCR
okay,
days.
fair enough. Okay, criminal justice, NCR days. Okay. Yes, sir, is like professor of three idiots. Okay. Delhi crime. Okay. Yeah, and I'm really enjoying it. Okay, people are really enjoying it with Yashri. I have been observing you for quite a long time, and you are quite supportive over here. So let us see how many others are there. Okay. So I think we can just move forward. Yes. What do you suggest? Yes, you are not audible. You are on mute.
Right. So I think we can move forward. So is my screen visible?
Yeah, I would be adding it. Yeah, its screen is visible.
Okay.
Just start showing it. Yeah.
Okay. So let us start with another problem, another interesting problem. Okay, I will say an easy problem. I know that. Maybe if everyone knows it, so we'll quickly cover it up. Okay, then reverse in groups and everything. I think Siddharth and Abhinav will be taking a lot of questions. Currently, I am taking the normal questions to begin with. Sanju, it happens every Saturday. Okay, so can we start with this question, Siddharth? Finding the middle of the linked list. What do you think?
Yeah, I think people are quite ready for this question. We can move forward.
Okay. So, okay, Siddharth. So let's quickly write this. First of all, write the linked list. Then we'll observe this. So let's write one. Okay, then one is connected to let's say two. Then two is connected to let's say three. Three is connected to four. Then four is connected to five. Then after five, you have something like null. Okay. So now, Siddharth, if you look at this linked list, so what do you think? Which is the middle node of this linked list?
For here, it would be three because if we don't consider the null
Okay.
thing.
Okay. Now, can I say that there will be a conflict in front of even size linked list when the number of nodes are even? Okay. So let's quickly check that up as well. So in
One,
this
two, three,
question,
four.
basically, I'm wanting to find the middle of the linked list, and let's see this.
Okay.
Okay, Siddharth, what do you think? There are two candidates basically for being the middle, I think, correct? So you will
Yeah,
take the median of
absolutely.
them. You will take
Yeah,
the median.
we could have taken the median, but it entirely depends on the problem what he has to. So what is the
Okay.
second
So
middle
the
element? That would be the next one.
so Yeah, so the problem says that if there are two middle nodes, so two middle nodes will be when the size, when the number of nodes is even. So in this case, I have six nodes. So when I have six nodes, then in that case, what happens? I have two candidates for the middle node. So in that case, it is saying that if there are two candidates for the middle node, that is when the size is even. In that case, you will print the second middle element, right? So in that case, what will you do, Siddharth? In that case, you will print the second middle element. So in that case, which node will you print? you'll print this node as the middle node. Okay, is this clear?
Okay. Yeah, absolutely. Yeah, absolutely clear.
Right. So, like any brute or any basic approach that comes to your mind, Siddharth, for solving this question?
Yeah, what we can do is, see, in the given, suppose we are given an array. So let's talk with respect to array. So if we are given an array, we can directly go to the middle index and then we can do it. Let's talk about the linked list.
So you're saying that
Talking about the
if
linked
there
list,
is an array, you're saying
yeah,
that if
if
there is
there
an
is
array,
an array,
there are
we
n
can
nodes. So you're
access
saying that
directly
the
access the index.
middle element will be kind of this thing.
Yeah, absolutely. We can do this. But in the case of linked list, we are not given this indexing thing. So what I can do is, first I would get the size of the linked list. Okay. So
Okay.
what would be the size of this thing? Suppose we just start from the very first head. So we would go to one, we would have one, then we would have two, then three, then four, then five, and six. So as we iterate, we can count the values that we are getting. So basically, we just need to count the number of nodes which are valid, okay, which are not null to be precise. Then what we can do is we can start again from the head and we can just move till the halfway. Can we do this?
Correct. So in this case, what you can do is, first of all, you can do one traversal for finding the length of the linked list. Suppose the length is n, then the n by 2th node, if you keep a counter for yourself, right? So let's say you keep a counter. Let's suppose that you start the counter here as 0, right? So in this case, what will be the n? N will be 5, Siddharth, correct? For this case, correct?
Yeah,
N
absolutely.
will be equal to 5. Now, if n is equal to 5, what is n by 2, Siddharth? I think it is nothing but 2,
Yeah.
correct?
So how it is
So
2? I
what I
would
will
be
do here,
telling you that also. So 2 is nothing but, so 5 divided by 2 is 2.5. But we are taking into consideration the integer division. That means that we would be lowering down the value to the nearest integer that is there.
because the data type is integer, because the data type is integer, we are storing it in integer, so the decimal part will be neglected. Okay,
Yeah,
so in
absolutely.
this case, what I will do here is, I'll say that, okay, counter is equal to 0 for this node, then I'll move to the next node. So in that case, I'll increment the counter, so counter equals to 1. Now in this case, I'll increment, now counter equals to 2, so I'll be at the middle node, correct? So because that is
Yeah,
what I wanted,
absolutely.
n by 2th node. Okay,
Yeah.
now if you look at the second case, so in this case n is equal to 6, suppose, right? If n is equal to 6 in this case, so what is n by 2, Siddharth? N by 2 is nothing but 3,
Yeah.
correct? So in this case, when I start, so suppose I start counter is equal to 0 here, counter is equal to 1 here, then I'll move to the next node, so counter is equal to 2, then in this case counter is equal to 3, so I have again reached the middle node, correct? So
Okay.
I'll be returning this node data. Is this clear to everyone? Basic approach, counting. Most of us must be very much clear with it. And I can see a lot of people are watching. So for those who have not hit the like button, you can hit the like button. Okay. For
Yeah. So
Siddharth, he
let's
has been
see.
hosting. He has been hosting for the very start.
So let's see
Yeah.
that what is the current like. The number of likes are only 91. It is even less than the current viewers. So can everyone increase the like counter of this video? Everyone quickly like this video. Let
We
us see the
want
like count.
Currently
1,000.
it's two. Currently it's
Yeah, the
200 to 1.
conditions are still the same. The if it is 1K likes during the live session, Abhinav would do the honors like before.
Sure,
Okay.
sure.
Okay. So after, like, the target is that after we end up this question, so we must be at 250 likes. Okay. Let's see what can happen.
It is
Okay.
already
Now
220.
this.
Let's try to make it 250. Yeah, we can move forward.
Okay.
Anish.
So
Yeah,
let's
yes.
move ahead, right? So there's another approach for it. Okay, but before moving that approach, see, there's another approach that is known as the fast and the slow pointer approach. Fast and the slow pointer approach. But like, see, there's a mathematical proof for it. But if I'll go into the mathematical proof, then it will take a lot of time. But I will give you another very basic thing. Suppose Siddharth, suppose there is a running track. Okay, suppose guys, there is a
Okay.
running track, and I'm asking this question from the audience. Suppose there is a running track. Okay, suppose there is a running track. Now in this running track,
Okay.
there are two people who are running, and obviously Siddharth is a faster guy, right? Sid is a faster guy. So Siddharth is a faster guy, right? And you can see Abhinav
I
seems to
think
be a little bit lazy. So let's say
I
Abhinav
think
is a
you should
lazy guy.
tag yourself as the fastest guy
Yeah, exactly.
and me as the slowest person. Please tag yourself as the fastest person.
No, let me take you guys for example, right? So
Okay.
if both of them are standing here, if both of them are standing at the very start, both of them are standing at 0, and I ask both of them to run. So if suppose that Abhinav is running at the speed of 1 kilometer per hour, okay, and Siddharth is running at that speed of 2 kilometer per hour. So basically, suppose that Siddharth is running at the speed of 2 kilometer per hour and Abhinav is running at the half speed. So which person will reach the end first? You can quickly comment down below. You can comment down Sid plus plus or Abhinav plus plus, like that.
So
Like
it
you can do
might
the voting
so
quickly.
it might be the scenario that either me or Abhinav would fail. Mostly me, because I'm trying to run double the speed of Abhinav.
So, so see, Siddharth is, and nobody will fall while running. Okay, so Siddharth is running twice as the speed of Abhinav. Okay, if Siddharth is running at the speed of twice of Abhinav, then obviously what will happen when Siddharth reaches the end? When Siddharth reaches the end, then where will Abhinav reach? Can you tell me, Siddharth, where will Abhinav reach by the time you have reached the end?
So if it is 2x, so it can be entirely thought of in this manner that I'm running twice of Abhinav. So I can say that if I'm reaching the end, then Abhinav would be in the middle of the whole track. I can see that.
Correct. And that can be proved as well mathematically also. If you want to prove this thing also, I know that there is a proper proof for this fast and slow pointers, but I'm just putting this in front of you in another perspective maybe. So Abhinav will be standing at the middle, right? And now we were thinking that I've made Siddharth as the hero, but obviously our lazy guy Abhinav is the hero here. Correct? Yes or no?
Yeah, exactly.
So
I
you can,
I am the one who's giving the answer.
right, so he is the one who is the actual hero here, right? Because he's standing at the middle. जब तक स्वेट लास्ट तक जाएगा तब तक अभी हाफ तक जाएगा. Okay.
Fair
Seems
enough.
great, right? Seems great. But what will happen? This is when the track is flat. So this is when the track is flat. Correct, Siddharth? This is when the track is
Yeah,
flat. Like there is, it is not kind of circular or something in nature, right? So in
yeah.
this case, what will happen here is what will happen here, I'll come to this as well, but like there's one conflict, right? Suppose, Siddharth, that the track is kind of this thing. Okay, suppose that the track, like this is a running track, suppose. Okay, suppose this is our running track. Okay, now if the running track is circular in nature, so I know that we can prove it mathematically. I'll not prove it mathematically, but like I'll prove it in this linked list also, so you can see it in this linked list. I'll prove it how they will combine, but I'll prove it practically and not mathematically. So in this case, what will happen if the track is circular in nature now? So in that case, what will happen if Siddharth is running at 2x and Abhinav is running at x? So in that case, what will happen now? They will at one. There will be a point of time when they both. What will happen, Siddharth? Can you tell us in this case when the when this thing happens?
So after a certain point of time, me and Abhinav would collide with each other.
Yes, definitely these two guys will collide. But that is for finding a cycle in a linked list or removing a cycle in the linked list. I think that question will be covered later on. In my question, I just have to find the middle. So in this question, I can assume that the linked list will be will not be having any circular path. So my linked list is what? My linked list is nothing but a flat track. Correct, Siddharth? My linked list is nothing but a flat running track. Correct. So let's
Yeah,
do this.
absolutely.
Let's quickly try to do the dry run on both the type of linked list, that is even size and the odd size. So suppose what will happen here. Suppose for slow, okay. Suppose there's a slow guy, so slow is nothing but Abhinav, okay. And suppose that the fast guy is nothing but Sid, okay. So what will I do here? So let me write this here as well. So just give me a second. So suppose I have slow, okay, and I have fast guy. So slow is nothing but the R Abhinav and fast is Siddharth. Okay. So initially both will be standing at 1. Then Siddharth is running twice as the speed of Abhinav. So Abhinav reaches what? Abhinav will reach nothing but 2. When Abhinav reaches 2, then Siddharth, where will you go? You will go at 3, correct?
Yeah.
You'll go at 3 because Siddharth, like Abhinav takes a jump of 1, Siddharth takes a jump of 2 always, right? He's
Yes, I
running
think
twice as the speed.
that. See, I think this is a little bit intuitive. This is a little bit intuitive that if I'm running twice as of Abhinav, so when I would complete the race, he would be at the halfway only. Okay, so we can directly move to the code. I think because this
Okay, but
mongoose.
just a quick dry run, because there's one more condition
Yeah,
that I wanted to focus.
yeah,
Uh,
absolutely.
like there's
Yeah,
one more. There's okay. So in this case, what will happen? Like then it moves to 3. Okay, so slow moves to 3, right? Then what happens? Siddharth will move to 5. Now, can you tell me, Siddharth, can you take a jump now when you are standing at 5? Now, can you take a jump of 2? No.
yeah,
Can you
absolutely.
take if you are standing at 5, so you cannot take a like you cannot take a jump of 2 now, correct? From 3 you move to 5, but now you cannot take a jump of 2. Why?
Yeah,
Because now the next is not available now. Now the next now for 5 its next is null. So if it is null, then there is no next of next available, correct?
yeah,
That is
absolutely.
happening here. So in this case, what you will say is, like, this is Siddharth. So this is nothing but the fast guy. So if the fast is equal, like if the fast next is null, in that case, I will have to stop. So I can say that if the fast next is null, right? In that case, maybe you are stopping. Right. Let's see it for the odd linked list as well, like even size linked list as well, and then we'll look at the code as well quickly. So let's suppose this is 1, 2, 3, 4, 5, then 6. Okay. Then it is pointing to null, let's say. Right. So suppose a slow pointer is there. Suppose a fast pointer is also there. One, I'm standing. Both are standing at 1 initially, right? So from 1 I move to 2. Okay. Then from 1 Siddharth moves to 3, right? Then Abhinav moves to 3, takes a jump of 1.
Okay.
Siddharth takes a jump of 2, so Siddharth takes a jump of 5. After that, again Siddharth, let's say, takes a jump of 2, so Siddharth moves to null. Okay, and what happens now? Abhinav moves to 4. Okay, so in this linked list, what is the middle element? The middle element was 4, Siddharth, as we had already discussed, right? The middle element was nothing but 4, and that is where my slow is pointing. Correct, my slow is pointing here only, and here also my slow is pointing to 3 only. Correct, that is what is happening.
Sure.
Now in this case I am stopping. Why I'm stopping? Because now the fast is equal to null. Okay, so in this case there are two conditions, right? For my fast, for the fast to keep on taking the jumps, I if like what is the stopping condition here? If the fast next is null, then I can stop, or I can also say that if the fast is null itself. If the fast next is null, that is here the fast is standing, and fast next is null, then a jump of 2 is not possible. Or if the fast itself is pointing to null, then also a jump of 2 is not possible. So these are the two cases when I should be terminating. Otherwise, I can keep on moving like this, and I will simply return the slow. Okay. So what will we do here? Let's quickly check that. So Siddharth, can you tell us how we'll write the code? Or Abhinav, can you tell us? So first of all,
Abhinav?
what we'll have is we'll have a node slow, and it will be pointing to the head of the linked list. Then
Okay.
I'll have a node.
Fast also would point to
Uh,
the starting position. So
correct.
both of us, the slow and the fast pointer, would point to the very starting position of the track. Just remember that. Try to visualize in
Right.
terms of a track, and you would be able to move it.
Correct. Now, what is the condition? What is the condition that my fast, if like, what is the condition when I should terminate? Like, when should I not terminate? So I will not terminate. See, if the fast next, right? If the fast next, I'm saying that if the fast next, I'm writing it like this. If the fast next, suppose if the fast, if I write it like this, in fact, if the fast is not equal to null, right? If the fast is not equal to null and the fast next is not equal to null. Correct, Siddharth? If both the conditions
Yeah,
are satisfied, then only I should keep on moving. Correct. If
yeah,
fast is not
absolutely.
equal to null and the fast next is not equal to null. If both the conditions are satisfied, if either of the condition is false, so if the fast becomes null or if the fast next become null, then I'll terminate.
Okay.
Right. So that is why I'm writing this. That if both the conditions are satisfied, then only I can keep on moving. And how will I move? So I'll say that slow is equal to nothing but slows next. In Java, they will be like in Java, there will be only one difference, that you will be using a dot instead of arrow. Okay, so what I'll
Okay.
do here is fast is equal to what? Fast is equal to nothing but fast is moving by two nodes, so fast is equal to fast dot next basically in Java. Right. Now in the end, I want to return the I want to return the middle data. So what is the middle data? No, I will not be using or. I'll not be using or. This is very important because both the conditions should be true. Then only my fast should run. Now, if suppose that the fast, if suppose that the fast is not pointing to null, but the fast next is null, then you are saying that you will iterate, but you will not iterate. Now, if the fast becomes null, right? If both the conditions should be true, that the fast should not be equal to null and the fast next should not be equal to null. That is very important for us here. Okay, now my slow will be pointing at the middle, so I'll simply return the slow data. That is, they are wanting the integer value, so I'll simply return nothing but the slow data here, right? That is what I'll be doing here. So let's quickly return it. In Java also, you will be just doing the dot operator, nothing else. So let's quickly see that how it's working. Seems to work on the samples. Let's try and submit it also to see if it works or not. Okay, so it does work. So this question is clear to everyone. Like at least the concept, like the running track example, maybe it must, like if you already knew this question, then that example would have been great for you.
Yeah, I think it is clear. So while we are waiting, I would just address few of the doubts. The first doubt was the first algorithm which was prescribed by me was big of n. Why? Because see, the first we are just traversing over it and we are getting the size, and the next one was that we are again traversing and we are only moving halfway. So we can say that we are doing 1.5 iteration. The first iteration, we are just moving all of the nodes, and in the next iteration, we are moving half of the nodes. Okay, but the problem would arise because when you would do this in an online judge, it won't make a difference because the constants are ignored in time complexity. That is in big O of notation. That is big O of 2n is same as big O of n. But the problem would arise when the interviewer would ask you, can you do this in only one iteration? Can you do this
Yes.
without traversing the same linked list again? So this makes
So in
all
the
the difference.
Okay, so in
So
the
talk,
previous approach, I'll explain this on the board as well. In the previous approach that Siddharth was talking about, which was the size approach, taking out the size, that takes two traversals, right? Two traversals of the linked list, correct, Siddharth? Two traversals,
yeah,
right? But here, what you are doing is you are doing it in one traversal. So that is what the interviewer will see. Okay, if this was asked in online just, then maybe what you have done is fine. But if the interviewer will ask, so he'll expect the answer in one traversal. That is why this is important. Okay.
yeah. See,
Uh,
in interview, the optimizations to an even a small bit is absolutely very necessary. Like he would go till the very bottom and try to get the most optimized one. Most of the time, this would be the scenario that would be needed. So now the next thing which was asked is, so I would just ask each one of us, okay, what is your take over this? So what is the note making strategy of Yash? What about you? What is the note making strategy for
uh,
you for a particular
for note
question?
making strategy. So see, there's obviously a
Key notes.
bookmark question, bookmark. So see, there is one bookmark thing that you can do, but we do not look at the bookmarks on the online judges or the websites like Geeks for Geeks or anybody. Like we do not generally go back to the bookmarks. So in that case, what you can do is you can like everyone knows about Google Doc, right? Google Doc or Microsoft Word, correct, Siddharth?
Yeah,
So
absolutely.
what am I audible?
Yeah, absolutely. You're audible.
Okay, so what you can do is, if you talk about making notes, so what you can do is you can use Google Docs or you can use Microsoft Word, and what you can do is whatever codes or whatever problems you find that okay they are important, so you can save them on Google Docs. By doing that, what will happen? It will be very easier for you to revise those notes because if you are using Google Docs, then your Google ID is logged in from the mobile phone as well as your laptop. So you will be making the notes on Google Doc, right? And you can access it remotely on your mobile or any other device or anything, any Android device. So in that will be very easy. So I'll suggest that you can make Google, notes on Google Docs, and it will be very easy for you to revise it later on by using Google Drive.
Anything
So
more
that is
you
what
would
I
like
do.
to add, Abhinav? Anything more you would like to add, Abhinav?
You are silent on
You are
mute,
on mute.
Abhinav.
You are on mute.
So sorry, yeah. So I'm completely agree with yes. So the strategy of making notes on documents and doc, that's a very amazing thing, and that's also actually a thing that makes us to revise things in a proper manner and to basically recall the things. For example, that currently you're learning linked list. Okay, so I will take a problem that is detect and remove a loop from linked list. That's a very complex problem that contains so many concepts in a single problem. Thing is that you are not going to revise that thing. That's it's not a thing to learn कि आप उसको revise करोगे. The thing is कि you have to just recall the things, recall the concepts, how you are basically finding the loop, how you are basically removing the loop. Getting this is the thing which we are going to do. So for that, documentation of things is very good technique to basically revise.
Okay, so my add-on to this would be that there are some questions for which you need bookmark or notes, but you need to understand the question for which you need. Like suppose you learnt a very new technique. You learnt a very new technique. So for that, you need to keep a bookmark and you need to revisit it again. But suppose you are solving a question today and you are not able to solve it, which would happen for most of the time, and then you saw the editorial and you were able to solve it. So, if there was a small trick involved in the problem solving part, then you don't need to write it. Even we, as competitive programmers, don't remember the solutions of the question which we have solved long back, and neither we do keep an account, most of us. Do you agree, Yash and Abhinav?
Yeah, completely agree.
Okay, so you need to understand that in the era of, so if you are doing problem solving and if you have learned a new technique, make sure you write it. But if you're just found a way of solving it, please don't write it. Because yes, the way of making notes, the way of keeping it is already told. But if you have a large number of notes, suppose you have a very large doc to cover, then you won't be able to revisit it. So make sure you only keep those notes intact which you need them. Not everything that you are learning the whole day, you are just summing it up in a notes or something. So make sure you do this too. Yeah,
And
yes,
also
I think.
let's
Yeah.
say you will add 100 problems, right? So that will be very tedious, and 100 problems will be from, let's say, 5 or 10 topics, right? So for that, what you can do is, what I do is I make it according to topic wise. So I write a note based on topics. Yeah, I was also looking at this comment. So Abhinav, you have any comments about it?
Avinav, any feedback from you?
Okay. So for those who were at who for those people who were in the previous stream, can you tell us, is there any difference in the video quality of Abhinav or not? And if you can see, then you can write a yes. In Abhinav's video quality, is there any difference? Can you spot any difference?
Yeah,
Okay,
there is
so the
like
recent change that is being made is Avinav
Most.
bought a new MacBook with his own money. So
yeah.
everyone quickly, Avinav
So you can
सबको party party.
so you can congratulate him here in the chat as well as in his LinkedIn comments, like in his LinkedIn DM as well.
Thank you,
And
everyone.
yes, you
Thank
can
you.
if you know him and if you know him, then you can ask for a chocolate too.
Yeah, sure.
Okay, fair enough.
Okay.
So we can just so I would just have it. Yeah. So yes, I think we can move forward. Do you have any questions left?
Yeah. At least one question I'll be doing. Then maybe if you want, you can take the lead from here also. But let's do one more question. Very simple
Okay.
follow-up question. Okay. Okay. So let's say, have you heard about palindrome, Siddharth? What do you think?
Palindrome. Palindrome seems like my
Yeah.
ex. Same from front, same from back. Okay,
Okay.
we can move forward.
So okay. Okay. What is a palindrome? Something that reads the same from the back and the forward. Correct. Right. So in this case, suppose I give you this array. Suppose Siddharth, I give you an array. Okay.
Okay.
And I give you this kind of an array. So is this array a palindrome or not? Guys, you can comment down yes or no. What do you think?
So
Is this
let's
array
try
a
to see.
palindrome?
If we try to see in this manner, this is 1, 2, 3, 4, 5, 6, 7. If you try to see from the backwards, it is 7, 6, 5, 4, 3, 2, 1,
So
and
if I
both
try to
are
see from
completely.
left to right, then in that case it looks like 1, 2, 3, 4, 5, 6, 7 kind of thing. Okay. If
Yeah,
I see it from right to left, then 7,
it would be
6,
7,
5,
6, 5.
4, 3, 2, 1. Correct. That is what will happen here. It's not palindrome, obviously. Let's take
Yeah.
another example and see what can happen here. Basically, there are many strings as well. Like you must have read this in your maybe 9th and 10th also. Madam, string is a palindrome, correct? So string, in terms of string also I'm talking about. So like let's say this is 1, 2. This is 3, this is 2, and this is 1. Okay, Siddharth, is this array a palindromic array? What do you think?
Yeah, it is, I think.
It is
I think
because
yes.
it it reads the same from back and forth. Okay. Now, if you want to check, how can you check that, Siddharth? Like, any idea? How can you check? Okay. Now, in this case, if you can, let's suppose that, let's suppose what is the question given. Let's also quickly follow this up. Then we can discuss further. So, in this question, I'm asking you to check whether a given linked list. I'll give you the head of a linked list, and you have to tell me whether that linked list is a palindrome or not. Okay, that is what you have to do. So let's quickly
So
check
can you
that up.
quickly
So
explain with respect to the array first, like how it can be solved in general if it is not a
yes,
linked list?
yes, we will come back to it. We'll come back to it because we will require
Okay,
that
sure.
concept only here. Okay, so Siddharth, what do you think? Is this a palindromic linked list?
Yeah, absolutely.
Yeah.
Okay. Now, Siddharth, let's talk in terms of array, Siddharth and Abhinav. So you have, or in terms of strings as well, you can talk. I have written the madam string as well, so you can talk in both fashions. Can you tell me how you can check? And maybe for counter case, I'll write another array. Let's say 1, 2, and 3 array. Also, I'm writing. So can you tell me how
Okay.
you can check or whether an array or a string is palindrome or not? How can you check that? Based on that, maybe we
So
can draw some intuition for linked list as well.
see, when was the first time you asked me if the array is small, we can just write it in the reverse order and we can just check it. But if the array is getting bigger, okay, we
Wait
can
a
see that
second.
in the
Wait a
back.
second. You said that we can write it in reverse order and then we can check it.
Yeah.
Okay. What does that mean? So let's say if I give you an array like 1, 2, and 3. So
Okay.
you are saying that you can write it from left to right. It will read like 1, 2, and 3, and from right to left it will read like 3, 2, and 1. So you are saying that it is not palindromic in nature, correct?
Yeah,
Now
I can do that.
if I
Like
give you an array like
having the
1, 2, and
corresponding.
1, if I give you 1 to 1, so
Mhm.
one you will first of all check it in the normal direction, that is left to right, then you will check it in the reverse direction, that is 1, 2, and
Yeah.
1, and the reverse order is 1, 2, and 1 again. But did I heard reverse? I heard reverse.
Yeah.
So can I do reverse in linked list as well? Maybe.
Yeah, you can do that.
Correct, guys? Can I do reverse?
Absolutely.
Because I heard reverse. I have just told you about reverse question. Correct.
That
Can I
was the
do
first thing
reverse?
which you discussed, no? Yeah.
Correct. So in this case, what I could have done is, see Siddharth, this is a normal linked list, right? I could copy this linked list maybe, and then what I can do, I can copy the same linked list, right? I'll copy the same linked list, that will look something like this only. And then what I can do is I can reverse this linked list. What do you think, Siddharth? I'll copy this linked
Yeah,
list,
absolutely.
and after that,
You can do that.
I'll reverse this linked list. And now what will be the pointer of the reverse layer? Like what will be the starting point of the reverse linked list? It will be nothing but the previous, as we have already discussed, right? Then I can check this guy with the head, right? The head data with the previous data. After that, I'll move my head forward, I'll move my previous forward. I'll move my head to the next node, I'll move my previous to the next node. Then I'll check the data. If it is the same, then what I'll do is I'll move I'll move my head here, like I'll move my head to the next, I'll move my previous to the next. Now their data is also the same. Then what I'll do is I'll move my head here, okay? Then I'll move my previous here. Now the data
Okay.
is again the same. In that case, I'll move my head
Okay.
forward. So head moves to one, previous moves to this one. Now it is again the same. So in that case, what will happen? Now both of them will be pointing to null. Correct, Siddharth?
Yeah, absolutely correct.
Right, that is what will happen. But suppose if it is not the same, then what will happen? Suppose this is 1, 2, 3. Okay. And the other linked list looks like this. Suppose it looks like this. So what do you think, Siddharth? The head is standing here and the previous is standing here in this linked list. Now they are not the same. So in like or suppose if it is the same for some time, suppose it is same here. They are same. So I'll say that okay, let's move forward. Let's move forward in this one as well. Now they are again the same. So I'll say that okay, let's move the head forward. Let's move the previous forward as well. Now they are not the same. So in that case, I'll be returning a false. Correct.
Yeah,
That is what I can do.
absolutely. Yeah.
Some people are saying stack based approach. That can also work.
Yeah,
Okay, that is
but
fine.
the space complexity would be big of n because we need to store all the nodes that is given. So given the size
Yeah,
of
we
the
need
linked
to
list
store
as
it. Yes, Siddharth.
yeah, so given the size of the linked list as n, we can store all of the nodes in the stack. So the worst scenario, the stack would have big O of n, so n nodes. So space complexity would be big O of n because we are using an auxiliary data structure. So over that, if you give this approach to the interviewer might ask you that can you do it in constant space or not? Okay. Yes, you
So
can move
any
forward.
other approach that comes to your mind, Siddharth, for checking whether an array or a string is palindrome or not?
See, when you give me a very long array, even when I don't know any algorithm, I can see that if I have a pointer to the first and the last, I would just confirm this and then I would shrink my size. I would first go to 1 1. Yes, they are equal. So I would move forward and I
Uh,
would go to 2 2. I would go to
so
1
you're saying
1.
that you'll
Yeah.
have a left and the right pointer like this, okay?
Yeah, I can do that. Next, as they are equal, that means till this point, this is a palindrome. Next, we would move forward to 2 and 2.
Now L moves here and
Yeah,
R moves here. Like L moves
yeah,
L plus plus and R minus minus. Okay.
yeah, absolutely. So L is going at this direction, R is going at this direction. And the point
Suppose if
at
there
which
was a
they
3,
collide.
Siddharth,
At this point,
now,
see, if at any point the corresponding elements are not same, we can say that this is not a palindrome. Because at each
okay.
of the point, this should be satisfied. So at any point, if this is not satisfied, then this is not the scenario.
Because basically the first element should be equal to the last element, the second element should be equal to the second last element. That is the concept, Siddharth, correct? That is what we are
Yeah,
trying to think.
absolutely.
Because if you talk about palindrome, so first should be equal to the last, second should be equal to second last, and stuff like that. Okay.
Okay.
Now, someone is suggesting the recursion approach, I think. But again, if someone is suggesting the recursion, that again will take some size in the memory, na? Okay. So Siddharth, how like can you think like it is it can I say that it seems very easy for us to check in terms of two pointers, but you were saying something like, let's say L is standing here, R is standing here now. So you were saying that how will you check that whether they are same or not exactly?
So I can say that the data is equal or not.
Yeah, that data is equal to is two and two are equal, L and R data is equal. Then you will move forward again. So L moves here,
You would,
and R will move here.
yeah,
Then
R would move there. After this point, L would be greater than R. L would be greater than R, and they would be crossing each
okay,
other
so you are saying that
basically.
okay, you are saying that
Yeah,
again they are same, so you will increment them. So after that, R will
yeah.
point somewhere in, and L will point here.
At this point, we can see that R is now, so L is now no more less than R. So
Okay.
at this
So
point, we
if they
can just
cross each
have a
other,
better, yeah,
so you are saying that if they cross each other, then you will say that okay, they are palindromic in nature. It is
yeah,
very easy,
absolutely,
correct? Yes or no?
yeah,
It
yeah,
is very
absolutely.
easy for us based on this two pointer approach to check it. Now, Siddharth, my question to you is, can I see there can be various approaches for doing this problem, but since we have a scarcity of time, so since Siddharth has suggested this approach in array, so I am trying to think whether we can do the same thing here or not. Maybe there can be more approaches, but we have a limited time. We want to cover a more variety of questions. So now let's try and move to this question. Let's try and move to this approach, and I'll try to code it up. Then we will see whether we can follow up with other questions or not. Okay. So let's see. If like Siddharth, I'm saying that suppose this is the linked list, right? So can I have one
Okay,
pointer here, Siddharth, and can I have one pointer here? What do you think? Can I have one pointer L here, another pointer
absolutely.
R here? What do you think? In the singly linked
Yes, I
list, can
can
I
do
have
it.
it? No.
Yeah,
How?
absolutely. So what I can do is I can move to the head part and then I can just traverse it and then I can find the last position. I can do that.
Uh, See, Siddharth, I'm saying that. Okay, you are telling me that okay, Yash, if they are the same, then you are saying that you will move your L here. But this is a
Mhm.
singly linked list, Siddharth. So can you move your R to two? Can you move
No,
your
we
That
R
is what
here?
we
cannot.
Can you
cannot
move
do.
your R here? This is something
Yeah.
that we
So
cannot do.
Abhinav, what do you think?
Yeah, we cannot do
So
that things.
guys, can you
I think
suggest us what we can do here?
a
Can you suggest us?
We are stuck.
Yes, Abhinav, you can tell us. You were telling us about something.
Yeah, I think that we can just use that reverse technique. So in the reverse linked list, then the first pointer will be basically the last pointer of the linked list, and we can just compare.
Guys, what do you think? How can we do this question? Like any idea, any intuition? Abhinav has said something related to reverse. Any idea? If I see the two like the two pointer approach that I was discussing, if that we were discussing in arrays, then I am saying that if an L starts here, suppose if an R starts here, so I'll check this guy with this guy, but I cannot move a R here. That is not allowed for me. So can I say that I want this part to look like this? Correct? Say that I want the arrows to be reversed in the reverse order. Correct? Like I from
Yeah,
one, like from the last node, I want to reach to the second last node. Correct, Siddharth?
absolutely.
So in this case, what do you think? What can I do? I can I want to check till
I
this point
can.
of time. So what can you do,
So
Siddharth? If I want to check it
we can
till
just reverse the second half of the linked list. Can we do that?
yes, we can just reverse the second half of the linked list, guys. Correct. They have said the correct thing. We can, Radhika, you are also saying the right thing. Recursion also is fine. Reverse the second half of the linked list. Correct. So what we can do here is, can I say that we can easily find the middle of the linked list? Correct, Siddharth, or not? We can easily find the middle of the linked list. Can I say
Yeah.
this? That
So
we suppose slow will point here, we can easily find the middle of the linked list. Then
yeah,
if I ask
absolutely.
you to
Yes,
reverse, if I ask you to
yes,
reverse from here, yeah.
yeah, yes. Just a bit of information. So I'm just editing the resume at the back end. So you can just ask Abhinav till this point of time, and I'm just also
Correct.
replying to the.
Yeah, sure. So Abhinav,
Thanks.
can I say that? Can I say that I want to reverse the second half because I can see that I want the first half LL. I want to move till here, and I want my L to move here. That's
Yeah,
all those things seem to be fine. But from here, from the
yeah,
second half, I want the arrows to be in this order. Correct.
yeah,
So
yeah.
if I have found the slow, right? Abhinav, why slow pointer? Okay. So in this case, what will I do here? If I see here, in this case, what do I want to do? Can I say that I want to reverse this part? Correct, Abhinav?
Yeah, exactly. Yeah, that is
So,
what it is.
so if you think about it separately, can I say, Abhinav, what do you think? Can you reverse this much?
So yeah, we can do that. Means we can just assume that that slow is the start of the linked list. Let's assume that
Okay, you are saying that
the
slow.
logic is exactly same. But in we have to just make a condition that when we are reversing a linked list, then we are making its head to point towards null. That is what we have to ignore, and else will be as it is.
Okay, so in this case, we are going to reverse this part because what we want is we want the pointers to look like this. We want one to point to two, the last node to point to the second last node, and the second last node we want to point it to the third last node, right? That is what we want. So in this case, we'll be reversing it from starting from slow. So again, I will write the same algorithm for it, guys. So I am just quickly doing a quick dry run. Suppose this is three, suppose this is two, suppose this is one, and this is where actually my slow was there, right? So this is this part I have just magnified it here. Okay, so is it clear, Abhinav? I've just
Yeah,
magnified it here.
it is clear.
Then
Yeah, yeah,
then I'll stick it back here. I've just magnified it so that we can be more clear about it. Okay. So then
yeah.
what will I do? Abhinav, can I say that the reverse linked list looks something like this? This is null. Now in the reverse linked list, can I say that the first node is pointing to null? In the reverse linked list, 3 should be pointing to null. Can I say that?
Yeah, but this is what we have to ignore, na? This is what we have to ignore.
No. Why we will ignore this?
Because then there
Uh,
is a break between the first part and the second part of the linked list, na, yes? Means
no,
currently
no,
2 is
that will
pointing
not be.
towards 3. No, that is okay. That is okay.
Uh,
Yeah.
Okay, so see what will happen here, right? Let's see. In this case, if I want to reverse now, so I will reverse it as it is. So in this case, what will it look like? I have
Fine.
already talked about the reverse part. So shall I tell it
Sure.
again, or can I skip it? Everyone can write skip in the chat if you think that we can like skip the reversing of this linked list. It will be starting from slow, and I'll be reversing it. I'll be reversing it. So when I reverse it, it will look something like this. It will look something like this. If I've magnified it, so it will look something like this, right? It will look something like this. Then 3 points to null. Okay. All of you can write
Exactly. Yeah.
skip in the
It is
chat.
clear, yes. It's clear, yes. They
Okay.
are saying skip.
Right.
It's clear, yeah.
Okay. Now, if you reverse it, right? So, Abhinav, what will be the head of this linked list? What will be the head of this new linked list?
It will be the
The
last
previous node.
node, or you can say previous of that reverse of
Yeah.
the, yeah, previous. Yeah.
Previous will be the reverse. Okay. Correct, guys?
Yeah. Exactly.
See, you see, people are saying that 3 के आगे वाले करने हैं reverse. You can also do that. You can also do that. But if even if you do this thing, that will also be fine. Even if you do this, that will also be fine. Okay. So what will happen here?
Yeah.
In this case, if you will see, so Abhinav, what will this look like? If I now try to tell you. So suppose if I like this was what? This was 3, 2, and 1. Now if I try to reverse it, so what happens here? If I'll see here,
Yeah.
so
So it will be like
it's 3
3, then 2 points towards 3, and then 1 points towards the 2. And then
and 3
3
also
to null.
points to null.
Exactly. Exactly. This is
Correct.
the thing.
This is how it will look like. Please write yes in the
Yeah.
chat. Sir, 3 तो last में जाएगा ना. See, if you want, you can do it later on as well. But I will tell you na, still you will get a condition. You will get a stopping condition. Don't worry on that. Okay.
Yeah.
So now, can you tell me, guys, what is the advantage here? Right. So I have reversed it. Now, what does the linked list look like? See, Abhinav, can I say that this is the head part? Right. So I
Sure.
can mark a current
Yeah.
here. Right.
Sure.
And
Yeah.
this is what? This is this. How
Previous.
can I access this? This is nothing but the previous, correct, guys? Everyone can write
Previous.
agree in the chat. Okay.
Yeah.
Then, are they having the same data?
Yeah. They are.
Are they having the same data, Abhinav? Yes, they are having the same
Yes.
data. In that case, you will move your current here. Okay. And you will move your previous here. So, is the
Previous.
current in the head now again having the same data?
Yeah. Yeah. Exactly. Again, they are same.
Okay. So now the current and previous both are here. So are they having the same data?
Yeah. Now they are same.
Yes. Okay. So now you will move your current to this guy. Okay. So you move your current here and you move your previous. Where will your previous move away now? Can you tell me?
So it will be at null, na? Null. It
Yes.
will be
The
at null.
previous will point to null. And now
Exactly.
when the previous points to
We
null,
have to.
I can say that the first half is equal to the second half. Correct, everyone? Clear with this part, everyone? I hope
Yeah.
that most of us are very much
Just write
clear
the
with
plus
it.
one. Just write a plus one and
All
just
of you
like
can
the string. This is
quickly write a
clear.
+1. Is this much part clear to everyone? I hope that most of us are
Just make
clear with this much.
300 likes in the stream, guys.
Okay, great. This much part is clear. Right. So that is what I'm trying to do here. Now, Abhinav, you might be having a doubt that, okay, what will we do in case of an odd linked list, maybe? Like even length linked list, maybe, right? You might be having a doubt.
Yeah.
So let's
We can
also,
take example of that. Yeah. I have a
okay,
quick
let's
example
take
of
an
that.
example about that around that as well. Let me know if this is an even size linked list or not. Let's say, okay. What do you think? This is an even size linked list, correct, Abhinav?
Yeah.
Okay. So what will you do? What will the middle? Middle will be this guy. As we have already discussed, slow will be pointing to the If there are two candidates for the middle node, then slow will be pointing to the second middle node. According to our middle finding capacity, it will be pointing to the second middle, right? We have already discussed this thing. Correct? Yes or no?
Yeah. Yeah. Yes, I think
Okay.
that in the last example, there was a small mistake that you have just made your current to 2, but that current will also move to null, na? Because 3 is pointing towards null.
Okay. Yeah. Sure. Sorry. Yes.
Yeah.
Current will also move to 2.
Yeah.
But if the
Thank you very
previous of the
much.
current moves to 2, correct. So in that case,
Yeah.
I'll stop. Right. So now,
Exactly.
sorry,
Yeah.
current will move to null. Sorry, I missed this part. I
Yeah.
just
Yeah.
thought about like right. I was okay. So
Yeah.
यार
now
बड़े
in
शायद
this case,
छोटी छोटी
uh,
गलतियां होती है
okay. So in this case, you will reverse the second half. Right. You will reverse the second half. How will you reverse the second half, guys? Again, if I see that you will reverse the second half, so what will happen here? Like you will reverse from this part, right? You will reverse from this part. So what will it look
okay
like, Abhinav? Can I say that this will look like
it
this?
would look like 1 is pointing to 2, 2 is pointing to 3.
Correct. That is how the reverse linked list will look like.
Yeah,
Okay. So
yeah.
yes, thanks for connecting, Abhinav, as everyone is saying in the audience as well. Right. After this, what happens? Your head is this guy, right? So let me just use a head here. Right. So head is this guy, right? So you'll have a current here,
Okay.
and what? How will you access this guy, Siddharth? Previous, na? Using
Yeah,
the previous, you will
absolutely.
access this. Correct, Abhinav? Okay. So in this case, what will you do
Okay.
after this?
And
Uh, do they
at
have
this
the same
point,
data? Yes, they
no,
have the same data.
they
So
have the
you'll
same
move.
data at this point.
So you will move them to the next. Okay. So suppose that this was different. Suppose that this was 4. Now, does the current and the previous now have the same data, Siddharth? Yes or no?
Yeah,
In this
absolutely.
case, no, it does not
Yeah.
have the same. No. In this case, if
Okay,
it is
sorry, sorry.
2 and it is
Okay, yeah.
4, yeah. So in this case, it is not having the same data because I just changed it. So in this case, I will say that I'll return a false because they are not having the same data. So the second node from the starting is not same as the last node from second last node from the end. Second node should be having the same data as the second last node. Okay, so that is not the same. So in
So,
that case, what I'll do is I'll say that okay, it's false. But in this case, suppose there was a 2. If there was a 2, it is the same. Then I'll keep moving my pointers forward. Now, when I move my pointer forward, so current will move to this 3
okay,
and previous will move to this guy. Then do they have
okay.
the same data, guys? Yes, they have the same data again because this is
Yeah.
nothing but 3, this is nothing but 3. They are still having the same data. If they still have the same data, in that case, I'll again move both of them. So when I move both of them, so where will they go? Now, since previous was pointing here and current was pointing here,
Okay.
now they will point where? They will now point to this guy's next. So in that case, what will happen? Someone was say like, see, now what will happen? Now current was earlier standing here, so now current will stand somewhere here, okay? And previous was standing here, so now previous will stand at null. So now, if the previous is equal to null, so in that case, the first half is equal to the second half. In that case, I can return a true because I'll be coming out of the loop. Is this part clear to everyone?
Sure.
Is this clear to everyone? This concept for this also, like the previous, whenever the previous, like we will iterate until the previous is not equal to null. After reversing, we'll iterate until the previous is not equal to null. Is this part clear to all of us?
Yeah, sure.
Others can also,
I think.
others can also
Okay.
write.
So the whole idea of this is that, see, we want in array what we did was we took a pointer to the very first node and the very last node, and then we were going from this point, we were squeezing, like this was going on the right hand side and this was going on the left hand side. So see, going on the right hand side, this pointer, it is allowed. From head we can move to the tail and it is absolutely allowed. But this right side going to the left hand side is not allowed. Why? Because this node would be pointing to the next node that is towards the right hand side. So how would we do that? If this was a doubly
Then
linked
singly
list,
linked
we
list.
would have if this was a doubly linked
Yes,
list,
sir.
we could have done it flawlessly. But this is a singly linked list. So what we are doing is we are just reversing half of the given linked list so that we can have the traversal from the right hand side to this side and in that direction from the left hand side towards the right hand side.
So
Okay.
basically, you are reversing the second half, right? So can we quickly write the code for this, Siddharth? What do you think?
Yeah, I think we can write it because the reversing is
Then
already covered.
yes. So after doing this, I'll also cover the complexity of it. Okay, I'll also discuss the complexity with Siddharth as well. So first of all, let me just copy the reverse code so that I will be using it later on somewhere later. We also have found the middle. So first of all, I'll be finding. I have also found the middle now, so I can use it directly. So just one second. Let me just copy that code as well. Okay. Now is this visible to the audience or not?
Yeah, it's visible. I will just make it visible. Just wait. Yeah, it's now visible.
Okay, perfect, guys. So see, first of all, I want to do what? I want to find the middle of the linked list. So how will I do it? I will do it using this thing, as we have already discussed how to find the middle. That is why I was covering the questions in a sequential manner. Maybe even if you knew this, so you can have a quick revision for it, right? So now, uh, okay. So what will you do here? See, now you want to reverse. So what will you reverse to that? You will now be reversing from where? You will not be reversing from the head. You will be reversing from the slow, na? You will be reversing
Slow
from the
pointer.
middle, right?
So
So
reversing from the middle. So we already learned about finding the middle of the linked list. So we can quickly
this
find
is
the middle of the linked list through the slow pointer. Okay. So slow pointer would be now pointing to the middle. So let's talk about the reverse also. So we already have a head and we can easily reverse. Yeah, you can move forward. Yes.
yeah. So we are doing what? We are first of all finding the middle of the linked list. Then we are doing what? We are reversing. Like we are reversing the what? We are reversing the second half of the linked list. Now, second half of the
Linked
linked
list.
list. Okay, we are reversing the second half. That is why we are taking our current as slow because I want to reverse from the second half. Right, that is what I am doing here. I'm reversing it from the second half. Once I've reversed it, so I'll have the access to the previous. Now what I'll do here is now let's move forward. So what will I do? I'll have a current that will be marking to the head like okay. That current will be marked as head. This is a good practice I have already told you because if you lose the head, in that case you will not be having the access to the front of the linked list. Okay.
Yeah.
Now what
So
will
in
I do?
majority of the question, in majority, as I told, let me just sum it up once again. In majority of the question, you would be told do this, do that, and return the head after doing all this. So in that thing, whatever you do, if you keep a copy of head, that would be the most feasible thing. Yeah, yes. Sorry for the interruption.
Okay. So what is the condition? When will I terminate? Any idea, guys? When will I terminate? I'm checking. I'm checking. So I'm checking current and the previous. What is the condition when I will terminate? Everyone can comment down in the chat. What do you think, guys? Quickly comment down. When is the condition when I'll terminate? Is there any terminating condition? Look at this. Look at this. Is there any terminating condition? Look at this. Look at this even size linked list. What is the terminating condition? When the previous points to null. Look at the even case, like odd case. Whenever the previous was pointing to null, then I will terminate. So I will keep on iterating till when? Till like if the previous is not equal to null, okay, till that point of time I'll keep on iterating. And if the previous becomes null, in that case what I'll do is I'll stop. Okay, so what I'll do is I'll say that okay, if the current if the current data uh, if the current data is equal to the previous data. So if the node from the starting is having the same data as the node from the end, in that case, what I'll do, I'll move both of them one step forward. Correct, guys? I'll move both of them
Okay.
one step forward as I'm
Sure.
discussing here. Like I'll just quickly discuss it once again. Like basically, my current is pointing here, and my previous guy is pointing here. If they have the same data, then current will move to the current's next, and previous will move to the previous next. Right? That is what I'll do if they have the same data. So in that case, what I'll say is that current is equal to currents next, and in Java you will just write a dot, nothing else is different. So what you will do here is previous is equal to previous next. That's what you are going to do here. So if they are the same, suppose that if they are not having the same data, then what you will do?
So
If
if
they
that
don't
is
have the
not the
same
same,
data,
then condition of the
then
palindrome would be broken. So at that instant, we need to return that this is not a palindrome.
so in that case I'll return a false. Okay,
Yeah.
indicating that it's not true, it's not palindrome. And suppose if I hit this condition, so that is previous is equal to null, in that case I'll terminate out of this while loop. Correct, guys? In that case I'll terminate out of this while loop, and when I terminate out of this while loop, then what will happen? In that case I can say that the first half is equal to the second half, right? The nodes from the starting is equal to the nodes from the end. In that case I will say that okay, the linked list is palindrome, and I'll simply return a true. Correct,
Okay.
Siddharth? What do you think?
Yeah,
Okay,
absolutely.
so let me just try and compile this code now to see if it works or not. I hope that I have not made any mistakes here. Okay,
Don't
node
worry.
star current redeclaration. Okay, I'm declaring it again. Okay, that was the issue that I was having here. Okay, let's not try and compile it.
The code is
Okay, works on the
absolutely very
samples.
long. Okay. So if he is able to do it on the go and he can implement it in front of you, then I think he is doing a commendable job.
Okay, so it got accepted, guys. You can see that it got accepted almost in the very first go. Just the current was declared again, so that
So it
was not
is,
an
so
issue.
to be honest, it is not the very first goal. See the number of correct submission count that has already been made. At the back end, a lot of effort is to be given so that in front of you we can submit it and we are able to do it in one go. So you can observe it
Right,
from the number of correct
because
submission made.
as Siddharth has said, this is not just a practice. Maybe we might have practiced this question one, two, or three times. But what we have done is we have also taught these questions in a lot of batches. So that is why the counter is high. So don't worry on that. Okay. Uh,
Yeah,
so
so that means that to be able to implement it on the go without any wrong answers or without any freaking out for the next 1 or 2 hours, we need to do a lot of practice. Okay,
correct. You need
so
to
I
do a
think
lot
it
of
is
practice.
done. You can just
But
explain
there
the
is
time
one more thing.
complexity.
Okay,
Yeah, tell
let's
us.
quickly go through the time complexity, and there is one follow-up question that somebody can ask. Can I say that Siddharth, like first of all, Siddharth, can I say that I have distorted the linked list by reversing the second half? Can I say that? I
Yes,
can.
we can say that. Yes, because the links are
But
distorted.
but but I can again reverse the second half. Correct.
Yeah, you can just reverse it
In that
back.
case, it will be restored. So I can restore the same linked list also. If the interviewer says
Yeah.
that you have distorted, so you can tell the interviewer that I can again reverse the second half because I still have the access to the slow now.
See,
So in
the whole point is like this. Suppose we have 1, 2, 3. Okay, if we reverse it, it would be 3, 2, 1. And if we again reverse it, it would be again 1, 2, 3. Okay,
correct.
this is the whole point of this. So let's quickly sum up everything. Okay, like because this problem uses all the concept that has already been told by Yash. Okay, so we first find the middle, which has already been taught, finding the middle of the linked list
So
by
for
using
finding
two
the middle,
pointers,
let's
by
say,
using
okay.
fast and slow. Yeah, you
So
want
it
to
takes
tell
order
me
of n by
this?
2 time for finding the middle,
Okay,
correct?
okay,
Let's say, okay. Then what do? You reverse the second half, correct? So that again you are
okay,
iterating through half of the nodes at least. So again, let's say it takes
okay,
order of n by 2 time. Okay. Then what happens?
okay,
You check, right? So this is for finding like this is for finding middle, right? This is for reverse the second half,
okay, okay,
right? This is for reversing the second half. Then I am checking, right? Then I'm doing another half traversal, right? You can say that half
okay,
traversal. Now I'm traversing this much, L is traversing this much, R is traversing this much, right? So half of the nodes I'm traversing. So again I'm traversing for checking, right? For checking it if it is palindrome or not. Let's say I take another order of n by 2 for restoring, right? Restoring the second half,
okay.
right, Siddharth? So
Yeah,
what do you think? What is the overall complexity, Siddharth? It is nothing but you can say order of 2 to the power n. To be honest, you can say that. Like, sorry,
yeah,
order of 2, like order of 2 and divided by 2. Can I say that? Basically, that
yeah.
is
Two would
this
get
is what this
cancelled
is not.
because see, this
Sorry,
is
sorry.
just like the
Uh,
idea.
and
See,
just
half. Yeah,
yes, Siddharth, you can carry on.
yeah. So this is just like the idea that half a piece of cake and again a half a piece of cake. Both would make one piece of cake. Again, one more half piece of cake. Again, one more half piece of cake. So you can see that you were given in total two cakes. So it is told that n plus n plus n, that would be 4n divided by 2. That would be nothing but 2n. Ignoring the constants, that would be big O of n. Am I correct? Yes.
So correct. Order of 2n is nothing but order of n only. So you will take order of n time overall, right? So that is how you can explain the complexity. Is it clear to everyone?
Okay.
Everything that we have discussed, finding the middle, reversing the linked list, checking, traversing, everything that we have discussed, everything has been discussed in this problem also. So that is why we kept this problem in this order. And this is not the order that we have decided, right? So that this is the order that is present in the SG sheet, GFG SD sheet, correct?
Yeah. Yeah.
So these questions
Absolutely.
are there in the GFG SD sheet. So you can do them one by one and then you will get it, right? So that is why we are promoting that you should do the SD sheet, because these problems, if you want a quick revision or even if you are starting, then you can maybe start with the SG sheet, GFG SD sheet. That will give you a lot of confidence and you will get a lot of idea about the problem as well. Okay. So this question is clear to everyone. So Siddharth, how many what is the like count up till now?
It is 288. So
Uh,
can we ask the
can we reach the 300?
289? Yeah, we would, if
Can
we
we?
achieve 300, we would start with the resume review right away. Quickly help us achieve 300 and we would start the resume review right away.
Okay, so
Okay, so let's start this 291. Okay, it's increasing. Let us see how more. Let us see. 300. It's done. Thanks a lot.
so
Okay.
do you want to have a resume review or you want us to solve more problems? You can tell us also.
No, people are asking for resume review, and I think that we should do it. So yes, someone told us. So let's have a quick questionnaire. Someone told us that we three are like three idiots. So quickly tell us who is whom, like who is Rancho and what is the other person?
This is going to
Who?
be controversial.
Huh? So how? So was the voice broken of Avina for me or just for everyone else?
Uh, he- Abhinav, can you speak again? Yeah,
Yeah,
it is a
is
little bit
my
disturbed.
voice
Abhinav, you can check
broken?
the question.
Is it?
Okay, it
There
seems
is a
funny.
little bit issue. Uh,
It's how the voice breaking.
uh,
It seems funny. Okay, fair enough. So let me
I
just
think
share
there
my
is some issue.
screen. At this point of time, I should share my screen.
I think people are writing for more problems, Siddharth. What should we do?
Let's have a quick break. Okay, let's have a quick break of just 5 minutes. I think only one resume would solve the purpose. Everyone would have a clear picture of it. Okay, let us just say it.
So we'll have just one or two resume reviews quickly, and then maybe I'll start with the questions again. I just have one more question. Let's see if we can do that or not. Okay, Siddharth, you can share
Yeah,
your
you can
screen.
start. Yeah, let's see. So, what do you think, Yash? This is a good resume in the first look. So,
Currently,
what? Let's talk
currently,
about
Abhinav,
the good
Abhinav, can you
points
take
in
up
it.
this because I am having a little bit network issue.
Just,
Uh,
just
Abhinav, you wanna
confirm
try?
that
Okay,
now
okay.
my
It's
voice
absolutely
is
no, it's not okay. I would do the honors. Okay, so let's talk about the first impression of this resume. This resume, in the very first impression, is very good. But the problem is that the skills that are there, okay, so most of the time the skills are accessed by the automatic resume checker. So even if you keep the skills at the lower point and if you try to highlight your projects or your achievements before the skill, I think it would be better. Talking about the next thing, work experience, you're a software engineer or analyst at Capgemini from 2022. You are which batch pass out? So I think, okay, you have mentioned it, okay, 2018 to 2022. I think the month is not very necessary because you can just mention from 2020, 2018 to 2022, and you can also mention the year of your high school, like your high school, so that the recruiter would know that if you had a year lag or something, like if you had a gap or something. Okay, so this gap and all, some companies do ask that if this gap is there or not. Okay, so make sure you just write it there also. Okay, talking about the personal projects, you have done a Sudoku solver which uses backtracking algorithm, which is the usage of data structures algorithms. Okay, so I will just talk about the pros and cons of this project. So I think Avinav, you can just mute yourself.
Yeah,
Avinav, can you quickly mute
am I
yourself?
audible now? Is it clear?
Yeah, you're audible now.
just
Okay, yeah, fine. Sure.
Okay, so till this point, just let me clear. So talking about the first personal project, which is Sudoku solver. So many a times it might be the case that you are not good with development, but making a project over the data structures and algorithms, you would be able to explain more, and you would be able to answer questions more. It is just like redirecting your dev part of the interview towards the DSA part. Let's talk about the next one, that is desktop assistant. Okay, which is a desktop by implementing a part of AI. So I think AI should be kept before Sudoku solver. Okay, and e-commerce, yes, this is also good. The ordering of e-commerce is great, but I think desktop should be ranked before Sudoku solver. And certificates and
basically,
all.
to summarize your point, Siddharth, to summarize your point, it
Yeah,
should be in chronological order because he has developed this project in 2001, 2021. That's the latest project. So the latest project should be upwards because most probably the latest project is better. You can see
yeah.
that
So
na
you can either
2021 this
use
e-commerce is
So you can either use two of the techniques. The first technique is that you show your best point first. Or what you can do is you can work in order of the recent things that you have worked upon. Talking about the achievements, founder of All About Programming. I think I have seen this. Okay, 3 star at this. Okay, good enough. So let's open it as he is the founder. Let us see. All About Programming. I think I have seen this person in LinkedIn. I came across this person. So, so I think he is using a bootloader kind of thing. Okay, so you have a lot of links that is mentioned. So try to make your website let less heavy.
It
So
should be fast,
you
I
shouldn't
think.
rely. Yeah, you
I
shouldn't
will
rely
just
on third party.
I will just recommend you that the landing page of the website should be something fast, maybe the landing page doesn't contain the more content. Content should be just small and curated, but it should be fast. Just a suggestion.
Okay. Okay, sure. Okay, any more suggestions from your side, Yash?
No, I think overall it looks fine. Maybe one or two internships. Okay, work experience is there. Okay, great. Like it looks fine to me.
Okay, so yes, we can just move forward now. So I will just unshare my screen, remove my screen, and then we can move forward. Abhinav,
Yeah,
is your
let's start.
network good enough to
Uh,
start?
yeah, I think that if my voice is not clearly audible, so it's fine.
Yeah, you can just take a try. If this is not a scenario, I would take the honors.
Okay, sure.
Backbenchers
Ah,
has been blocked. Okay. Backbenchers was entertaining to me. I don't know where he went. You can mention your projects and all. You can glorify your open source. You can glorify your DSA if you are coding guy. Okay, some more resumes. Today we would be see the resume review session would be done separately. As of now, the current resume review was done so that we could have a break in a very productive manner. I hope you got the point. But the resume review session would be done in one more session. It would be done individually. It won't be merged into this problem solving thing.
Siddharth, is my voice clearly audible now? Is it breaking or not?
Yeah, you are absolutely audible.
Yeah, sure. Thanks for confirming. I think that now we can start now. Now we can start.
Yeah, you can quickly share your screen. I would add it to the stream when you open your problem page.
Yeah, sure. So the first problem which we are going to discuss is something this, which is that we are given with a linked list of zeros, ones, and twos, and we have to solve this given linked list. So this a similar type of problem is also present with arrays. That there is an array consisting of zeros, one, and twos, and you have to solve that particular given array. Okay. I hope that now my screen is clearly visible, and we can continue now. Siddharth, can you please confirm?
Yeah, it's absolutely clear.
Yeah, it's
No
fine.
more robotic
Sure.
voice coming from your side, Abhinav.
Okay, thanks. Yeah. So yeah, this type of thing is there that the linked list is contained of just zeros, ones, and twos. Okay. So this is a thing which we have to focus on basically. Now the thing is that when this similar type of problem is given to us in arrays, let's say that we are given with an array of this similar type of problem. Okay. Fine. So let's say that we have an array. Okay. We have an array containing zeros, ones, and twos, and we have to sort that array. First, let's say the array is 1 0 1 2 2 0 1. Let's say that this is the array, and we have to sort it. Which technique should we use? Just in the comment, which technique should we use to solve this particular given array? Siddharth, can you just tell me how we can solve this given
This
array?
is an unsorted array. So
Yeah, this
we
is the
can
unsorted
just
array.
so we already know that 0 should come before 1 and then 2 should come. So what we can do is we can quickly count all the number of zeros, all the numbers of 1 and all the numbers of 2 that is present.
Fine. So this is what we can do for array if there is an array present. Can we do the similar thing for a linked list too? This similar thing that count
Ye-
is zeros, ones, and twos.
Yeah, see, the whole point of counting the zeros 1 and 2 is all about traversing in the array. So traversing is present in a linked list too. So yes, we can move forward with that.
Sure. So we can take three counters, one of zero, one of one, and two, and then we can just place first. Let's say that there are z number of zeros, o number of ones, and t number of twos. So we can first make z zeros, then o ones, then T2s. This is what we can do now. This is what we can do. So for that, we have to first make a count of all the numbers. Fine. Now the thing which we have to say it. Fine. That can we do without counting this thing? Can we make it by changing the links? Because we have a next pointer. So let's take that the link list given to us is like this: 1, 0, 1, 2, 2, 0, 1, and then null. It is just similar to what we have here in the array path. It is similar to that. Okay. Now let's assume that we have to do it just here. So for that, what we have to do is that, let's say that currently our 0 is pointing towards 1. So what we will do, that we will make our this 0 points towards the next 0. Getting? This is what we have to do.
Yeah.
Now, similar for 1 also, we have to make this one points towards the next one, and this 2 point towards the next one. Similar for 2, we have to make this 2 point towards the next, which is already there. So in this way, we have 3 different linked lists, but it is not a separate one. It is the same one. Okay. Now let's say that let's just make these 3 linked lists separate. So for zeros we have
So
0
basically,
to 0. Yeah.
So basically, you are saying that you have pointers that are having the starting of the first 0, that is having the first
Exactly.
0, first 1, and first 2. And
Exactly.
what you are doing is you are connecting all the 2s together, all the 0s together, all the 1s together, and then you will be using them to concatenate
To
further.
merge. Yeah, exactly. That is what I was thinking. Yes, you are absolutely right. Okay. So this is what we have to do. We can do basically. So it's like that. Then we will have a something of 1. So it will be 1, 1, and 1, and there will be 2 and 2. And now we can just merge this from 2 to 1 and from 1 to 2. Getting? Am I correct? Yes? Can we do
Yes.
like this?
Uh,
Okay.
I'm clear with
Just
this.
a
What about the audience?
just a plus
Is the
1 in the
audience
chat if
also
this
getting
thing
this
is
idea?
clear. Is this thing clear, guys? Let's start a plus 1 and then we can just move forward. Okay? Fine. Okay. Great. Great. So they are getting fine, guys. So this is how we can just solve the problem. That we can just so let's take 3 pointers. Okay, just try and the approach what we are trying to implement. Okay, in this given question only. No, the time complexity will not be high because we will just iterate once. Let's make a dry run, guys. Okay, let's make a dry run and then we will make a check on the time complexity. Okay, that how the time complexity will be. Okay with this? Fine. Okay. So let's take that we have a first pointer which is a 0. So currently it is, you can say null, or it is nothing is there. So let's say it is null currently. Okay, it is pointing towards null currently. Okay. Similarly, we have a 1 pointer, and similarly we have a 2 pointer.
Abhinav, it will be great if you can use different colors. I'm not sure whether you can use or not, but for
Yeah,
0, you
sure,
can use a
we
different
can.
color for pointer and stuff.
Sure. So let's take like for 1, it will be currently null, and then let's take for 2 a black color, it will be null. Okay. And now what we will do is that we will have an iterator. Let's take the head node. Okay, this is the head node. So because this head data is 1 and currently our 1 pointer is pointing towards null. So what we will do, we will make our 1 to point towards this particular node, which is the 1, which is the head node. So now if we will just write on this, now our 1 is currently pointing towards null, 1, this particular one. Okay, then we'll move forward. Then our head is something pointing towards here. This is our head. Okay, now this head's data is 0. So now we will make this 0 is equal to 0, this particular node. Okay, let's, because we have to just make take check of. So it's like 0 and it's like 1. Great, guys. Now let's again update the value of head. So now this is the point where you have to just observe. Now again there is a 1. This is the head. Okay, now again this head is to be added in this particular counter. Is this thing clear? Can we take 3 count variables in single traversal only? We can find instead of 3 traversal. No, this is what we're doing. Single traversal only, not in a 3 traversal. Just a single traversal will be needed. That's the basically the logic. Tanay. Okay. Yeah. So this is how we are doing, and that you can see that the 1 was also added in the 1 and 0 was also added there. And then when we will move towards the 2 part, when our head will go towards here, it will be assigned to this. And similarly, it will just move forward. We will just iterate once. We will just iterate once. Is this thing clear to you all? Okay.
That's clear.
Okay. So I think that now we can move towards the code part.
Okay, so
Fine.
before Abhinav moves to the coding part, let me just sum up, and Abhinav, you can draw in the code. So,
Sure.
Abhinav, so we already have an unsorted array, and we need to sort it. So what we can do is we can try to distribute the linked list. Okay, first we have 0. Okay, so initially every 0, 1 and 2 would be null. And then whenever we receive 1, we just keep it here. See, we got a 1, we would keep it here. We got a 0, we would keep it at the point where 0 is present. We got a 2, we would keep it here. Then what we do is at the end, we already have, if there is 0 as well as 1 as well as 2 that is present, at the end we would have 3 of the linked list. And we would just join them together so that
Exactly.
we would have a whole damn linked list which is
Yeah.
sorted.
Now let's
Everyone
discuss
clear?
how we can join them. Now let's discuss how we can join them. Okay. So for joining, it's very clear that we will have our 0 pointer basically at the last node of that 0th linked list. And let's say here we have our Z, here we have our O, and here we have our. So let me first just complete this. Okay. Let me just first complete this thing according to our input linked list. Okay. So this is our linked list. So at the end of our traversal, what we will get? We will get 2 zeros like this. We will get 3 ones like this, and we will get 2 twos like this. Okay. Now, when we have to just merge them or join them, then what we will do? We will simply make the next pointer of this last node of 0 to 1, and similarly for 1 to 2. This is how we have also joined the 3 linked list. Now you can see our linked list is starting from 0, 0, 0, then 1, 1, 1, then 2, 2. This is how the things are going on. Is this clear to everyone?
Yes,
it's
yes,
it's not
big count.
it's not creating the 3 different lists. You can see one kid. Maybe you will see that you will assume that we are taking extra space, but that's not the case. We are just using these nodes only to create new list. Getting or not? We are not taking any extra space. We are using these lists only. We are just changing the link. So currently, let's say what I am trying to say, that currently the link of this one was towards the 0. Now what I am doing is I am just making it like this. Similarly for the 0, I am making it like this. This is how things are going on. We are not using any extra space. That's how we are
Okay,
making it optimal. Yeah.
okay, so I would just sum up what Abhinav is trying to say. So it seems like that Abhinav is trying to have 3 linked lists that is there. At the end, he would merge everything and it would emerge as a new sorted list. But this is not the scenario because these all pointer is nothing but the address to a particular person. Okay, because suppose I am standing and behind beside me, Abhinav is standing, and at this side, Yash is standing. So what I'm trying to do is I'm just trying to make Yash, and we are just reordering things. Like after Yash, Abhinav would be the person. After Abhinav, Yash would be the person. So we are basically reordering, and we are not using any new thing. So suppose one is looking to 0 in the original linked list. But what we are doing is in the next iteration, we are trying to point 1, go to the next one. That is why he has written down or the scribbled down in the original array. See, 1 is now pointing to 1. So the original elements are not changing. We are not taking any auxiliary something, but we are just changing the links. So links are being changed, but the elements or no new space is being allocated here. Yeah, am I correct,
Exactly. Yeah.
Abhinav?
Yeah. Sure. You are absolutely right. Yeah. So this is how we can do. Yeah, Vidyasri, that's maybe a confusion that when the whole iteration will be end. So that pointer that where the 1 is there, that will be at the end of the linked list. That is what we know. But we will also keep track where our 2 is. That we will also store, let's say, in a separate pointer. So in the case when we have to make our 1 next is equal to 2, then that will be the case. So when we will just implement the logic in the code part, then you will just get it better. Okay, so let's move towards the code part. So is everyone okay with the code part? Is everyone okay with the code part?
Yeah, absolutely. We can move forward with the
Yeah,
code.
so I think that now we can move forward with the with this thing. Okay, fine.
Yeah.
Sure. Okay, fine. So now I hope that now my code screen is visible. So let's do this thing. Okay,
You can
let's
just
write
make
the
it full
code.
screen. You can just
Yeah,
make it
sure.
full screen.
Sure. Okay, yeah, great. So first of all, what we will do, there will be some corner cases also. The corner cases will be that if the size of a linked list is just empty, means there is nothing, or if there is only one element present, then there is no need to sort it. That's the corner case, let's say. So let's make, you can say the base case or the corner case. So it will be like that if our head is equal, you can say, or you can say, write it like this also. If our head is equal to null, okay, or we can write it like that if our head next is equal to null, okay, then there may be a case that we can just do this thing. So in this case, we have to just return the head. Okay, Siddharth, is there any other logic to check that whether our head is null or not? Is there any other logic to check?
Yes, but it is not accepted all the time. So what you can do is you can just have, instead of head is equals to null, we can just have not head. If not head is true, we can say that yes, head is equals to null. We can have that. Or head dot
Sure.
next, and before that we can have not.
Exactly. So we can just write here a not, and similarly for this head next, we can write here a not instead of this thing. Okay. So I hope this thing is clear. Fine. Fine. Okay. Great. So this is the base case. Okay, where we are just doing the things. Okay. Now the
Okay,
next thing which
so
we have
just
to do.
so yeah, just a sec, Abhinav. So
Yes.
what Abhinav did was, see, whenever the head is a valid node, suppose head is containing the node 5, so not 5 or not node would be equal to null. That is a false condition. Okay, but when null of not of null is there, then not of null would be true. This is just like the condition that not yes not true is equals to false, but not of false is equals to true. So make sure that if this not is before the null condition, it would be true. If this not is before the valid condition, then it would be false. Yeah, you can move forward, Abhinav.
Exactly. Yeah. Sure. So now what we can do is that we have to take three dummy nodes, as I told, and that three dummy nodes will basically initialize with, it will start from where the 0 is, where the 1 is, and where the 2 is present. And then with the help of that, we'll just create, with the help of these nodes only, we will create three separate linked lists. It seems like that we are creating a new linked list, but it is like we are just changing the link. We are just rearranging the nodes to create three separate linked lists of zeros, ones, and twos. Okay. So for that, what we will do, that we will take this type of node. Okay. Fine. So let's take a 0. Okay. And it will be a dummy node. Okay. So let's take it like 0 is equal to 0. Okay. And similarly, we will just take the three nodes like this. Okay. Let's just copy paste the thing. Okay. So it will be 0. It will
Abhinav,
be 1. Yes.
Abhinav, I think you can take it as -1. That will be more intuitive for us as the dummy node.
Yeah, we can take it, sure. But the thing is not that the values will be 0, and because we will also take a duplicate node of this. Yes. Okay. So what we will take on that, we will, because the thing is that we have to keep track on the first node of each separate linked list and the last node too, so that we can join them. So what I will do, that after creating these dummy nodes, I will also create a duplicate of that, and that is what we have to go into iterate, getting or not. So that is what we are going to iterate. Okay. Yes. Fine. So now what we will do now, that to make a iteration, we have to take a duplicate node. The reason is the reason behind that is because the value of the node will be changed when we will just iterate to the given linked list. Okay. So we will make some duplicate nodes. Let's say Z. Okay. It will be like this. Okay.
Don't take it
Fine.
like this, Abhinav. Take it like tail Z.
Yeah, it's
Tail
also
Z
okay.
will indicate. Basically,
Yeah,
he's saying that while he'll be making the nodes, one by one, let's say he's connecting all the zeros one by one. So he's saying that he should stand at the head node. Head node should not be lost, because if he loses the head node for all the zeros, ones, and twos that are connected, in that case you will be in trouble, right? So he's saying that he will also take a tail node. So with the help of tail node, he'll one by one keep on adding the nodes, and the head will still be preserved. And whenever he'll require it, so he will use it. Correct, Abhinav?
exactly. Thanks. Yes. Okay. So this is how we can do
You
that.
can,
N-
Abhinav, you can put some enters because it is coming in the screen, so you can put some enters.
No,
Sorry.
it's
You can
fine. I
put
would
some
just hide
enters.
the banner. I would just hide the banner. It's fine. We can move
Okay,
forward.
fine.
No,
Okay.
it's not needed,
Okay.
Abhinav.
Fine. Okay. So now what we can do is that now we have to iterate through the linked list, so the original linked list, the head node which is given to us. So for that also we have to preserve the head node. There is a suggestion for you guys that don't use the exact head node for traversal, because then you will lost your head node. Always take a duplicate or a pointer pointed towards your head. Just let's say current for now, and use that to traverse so that your head should not be lost. Okay, fine. So now it will be like while this current will be there, we can also write current is not equal to null, but it will be like that while current is there. Okay, we can just write it like, then we have to iterate. Okay, fine. Now guys, there will be three conditions: either the data of our current node is 0, either it is 1, or it is 2. Now this is the exact thing which we have to do now. If the data of our current node is 0, okay, then we have to append it to the zeroth, this particular. If it is 1, then we have to append it to the this 1 node, or to the 2 node. So it will be something like a switch condition, or we can make a if else type of thing, conditions, so that we can just make check off. Okay, so let's make it like
Uh,
yeah,
One more
yes,
thing, Abhinav, it will be great if you will write current is not equal to null, because I think in Java it is. I'm not sure. I think in Java it is not possible. So for Java people also it will be great. And you can take it
sure, it
as
will be.
capital null. Uh,
Sorry for that.
Null is
Yeah,
capital in C++.
yeah, sorry for
Everything,
that. That
each of the alphabets.
yeah, I know. Yeah, sorry for that. Okay, guys. So this is how we can just do that. Okay, great. Now, the thing is that we can make just checks. So the first check is that if current data is equal to 0, that's the first check. Similarly, we will have two more checks, that if it is equal to 1, or if it is equal to 2. Okay, fine. So now the thing is there. Let me again explain this thing to you. So if our data, let's say that we are here, our current is here, and let me first erase the all the other things to avoid any confusion. Okay. Now, guys, let's see that this is our 0. For now, it is our tail 0, because that is what we are traversing. Let's say this is our tail 0, or tail Z it was. Fine. Yeah. It is a thing. And currently our current is here. Fine. Now see what we have to do is, what we will do, we will make our tail Z next equal to current. Okay. Equal to current. Now, what we will do, now this our tail 0 next is equal to current. Fine. Now we will also increase the value of this tail Z, because now we want that. Just see one thing. Let's say that this is our tail 0. It is pointing towards a particular node. Maybe it is a 0 before that. And this is our current. This is our current. It is 0. Okay. So now our tail next will point towards 0, which is currently is next. Okay. Now what we will do, we have to also make check of current. Our current will now become here in the original linked list, and our tail Z will now come here.
Correct.
Are you getting this thing? Are you getting this?
Yes, I'm getting this.
Okay, this
I'm
is
getting
how we
this.
have to just make check. So you guys are having problem na, that how we can just append the things, and how we can just change the link of the given linked list only. This is how we have to do this. Just write a +1 if this thing is clear. Otherwise, I will just explain it again. Just write a +1, guys, and you guys just tell me that if guys are understanding the thing. Okay, fine. Okay, Great, guys, great. So this is how we can. Okay, one more time. So yeah, sure. We can do like that. We can explain, do it one more time. So let's see that. Let's say that currently our current is here. Okay, our current is here. Okay, and currently this is a dummy node where our tail one is. Okay, our tail node is currently at the dummy node. Okay, and our current node is currently pointed towards 1. Okay, this is, I hope, fine. Now we have to basically make track of these one nodes a separate one, zeros as a separate one. Now what we will do, the first thing which we have to do is that we have to make this tail next equal to current. This is the current node. So now our tail node is equal to this current node, which is 1. This is similar. This node is now current here. Fine. Now we have to also update the value of our current, because we have to also traverse to the original linked list now. So now our current will be something like here. So what we have done now, we have taken this node, we have stored it in our tail one, and then we have just moved forward with our current node. And because we want our tail one to be at the last node of our one's linked list, so we will also make tail one is equal to tail one next. So now our tail one will also be at this position. Getting? This is how thing will be. Now let's take one more thing. Now currently our tail 0 is here, and now our current is 0. Again, we will do the same thing. We will make our tail z is equal to current, which is currently 0. Then, so the first thing is we have to make our tail z is equal to, tail z current is equal to tail z next is equal to current. The first thing. The second thing is we have to make tail z is equal to tail z next. Okay. So now this tail z will come here. And the third step will be that we will make our current is equal to current next. So this current now will come here. So in these three operations, what we have done is that we have basically appended the 0 in this particular linked list. This is how we will similar this thing we will do for 1, 0, and 2, all the 3 numbers. Okay. Fine. Is this clear, yes? And Siddharth, is it clear?
Yes, it's clear.
Okay, fine. Great.
Okay,
Yeah.
so I would just quickly explain what Abhinav is trying to say. And see, many people have this query, isn't he creating a new thing or not? So see, basically what we need to do is, suppose we just have 1, which is pointing to 2, and 2, which is pointing to 0. Let us take a very small example. So suppose we want to keep the first linked list at this point. This is the second linked list, and this is the third linked list. And the first one is for 0, this is for 1, and this is for 2. But the problem arises that, see, here in when we are explaining, we can write that this is the first linked list, this is the second linked list, and this is the third linked list. We can do that. But see, in programming, we don't have any arbitrary space to store everything or write everything. So what Abhinav is doing is, he cannot initialize a pointer with a null because null can't point to anything. That is why he is initializing a pointer with a 0, 0, 0. Then he is coming to 1, and then he is making 1, 0. See, this is for 1. So he is making this 0 point to 1. At the next instance, this is for 2. Okay. Then he is coming to 2, and he is trying to make 2 point to this. And then he is coming, when he is coming to 0, he is trying to make 0 point to 0. So see, by initializing with a 0, 0, 0, we are just using 3 variables, but that facilitates us to have 3 linked list, not 3 linked list, but it facilitates us this, that we can allocate this. And we are not, I'm just making it sure that we are not making this because, see, we are just trying to point it to a particular direction. Okay, we are just changing the direction in which the pointers are. We are not changing the element, rather, neither we are copying that element. Make sure you understand this. Yes, we can move forward, Abhinav. Sorry for the interruption.
Yeah, sure. Thanks for that. So yeah, so let's now like the exact three statement which we have discussed. The first was tail z is equal to next. Okay, tail z next is equal to current. Okay, this is the first thing that we will do basically now. Okay, so let's do that thing. Okay, so it will be tail z next is equal to current. Fine. Now we'll make our tail z is equal to tail z next. Okay, and then we will also increase, so we can increment the current pointer after all the three conditions. We have the three conditions now.
Correct.
Fine. So
Correct.
now
Correct.
we can make it like else if. So similar thing will be done here, but now for tail z. So now if our current data is equal to 1, that case what we'll do, instead of this tail z, we will just do the same, but now we will do that for tail o, which is the which the tail pointer of our one linked list containing the ones. Okay, this is what we have to do. And the similar thing else will be that if there is a 2, then what we can do, then we can just make it for tail t. Okay, and then in the while loop we can just write that current is equal to current next. This is a very basic condition how we can just iterate using the current.
Correct.
Fine. Now this is the half part we have done. The next part is to join these three linked lists. The three linked lists are, it's not a three set, it's basically we have changed the links of the linked list. Okay, so we have to again join them to a single linked list, and then we have to just return the head. Okay, so now what we can do here is that we have a three links like tail z. It's basically a tail elements. Okay, fine, great. Now guys, what we'll do is there is one thing which we have to observe. There's a one thing which you have to observe, that for this one linked list, for the linked list which is containing ones, its start point is just 1 and its end point is this tail o. So what we have to do is we have to do something like this. If this is our 1, this is our or let's make it for 0. Okay, so let's make it like something like this. If this is our 0 and this is our tail z, means the tail of 0, then we will have 1, then we will have tail 1, then we will have 2, and then we will have tail 2. Getting or not? Is this thing clear or not? Okay, this is what we have to do. So now we have to basically make next of our 0, or we can say tail z ka 0, the next of our tail z. Okay, sorry, the next of our tail
Correct.
z to 1. Getting to 1.
Not to one, but once next, no, because 1 is a dummy node itself, so it is storing a 0 as a dummy
Yeah,
node
it's
initially.
once next basically. Yeah, for here I am just saying it's a once next. Okay, so 2 once next,
Next.
and similarly for tail zeros next, 2 2 2.
Once next to two's next.
Fine,
Tail zeros,
and then
tails once next to two.
yeah,
Correct.
then tail t is next to null. Okay, these three things we have to make, but we have to also take a check that if this is present or not. We have to also make a check of it, that if one's next is present, means if there any one is present in that particular node or not, in that particular linked list or not. Because that is also a case that there is no one present in a given linked list. That's also a case, no? Right, guys?
Correct.
So great. So now let's code this part. How we can just
Abhinav, you can just increase the font
Can
size.
okay, sure.
Yeah,
Is it
it's
okay now?
fine. Yes. Yeah, it's fine.
Okay,
Absolutely.
great. Thanks for that. Yeah. So first, what we'll do, we will join 0 to 1. Okay, this is what we have to do. So we will simply write that is what which is given here also. Okay, so we will take our tail of z and we'll try to connect it with 1 once next. So we will make our tail z next equal to what? Equal to our
Once next.
once next. But if
But it should
once
be
next is
available, no?
not present, yeah. So we can, I think that we can use here the, it is something like this, that if once next is present,
If once next is not equal to null,
yeah, we can write it like this.
you can
Also.
write is I'm not sure in Java, no, so you can write it not equal to null so that Java people are
Yeah.
also clear with
Okay.
it.
Sure. Okay. Yeah. Great. Now, if it is not there, then we have to then we will directly make it equal to. Then we will directly make it equal to 2 next. Got it? And obviously, if 1 is not there, 2 should be there. That's not a compulsory case, but yeah, you have to make check of that too also or not. Okay. And then what
You
we'll
can check
do is,
that.
yeah. Okay. Fine.
But it is not necessary because if it is even if it is
Yeah.
null, then it will be initialized. Its next will be updated as
To null.
null. So
Exactly.
zeros next will
It
be
should be
updated
null.
as null. So it will be neutral.
Exactly. It will be neutral for us. And the same thing we will do for 1 also. That to make our 1 or it's basically a tail 1. Okay. Just take a watch what I'm writing. Yes. Okay. Where there is very confusion 1 and tail 1 now. So it's the tail 1's next should be equal to 2 next, I think. And then we will make our 2 next is equal to null or not. Is it clear or not? Or let's say it's tail 2. Sorry, it's tail 2. It's tail 2. Is it clear or not? So currently what we are doing, that we are making a tail z to 1 next. Okay. Then our tail 0 to 2 next. And then tail t2 next to null. Okay.
Okay.
Fine. And also what we have to do, we have to return the head pointer. So
We should.
currently our head will be at the next of our, I think that's the dummy node of 0. No? So our head will
Correct.
be at the next of the dummy node of 0. Oh, sorry. Fine. And we can just return the head, I think. Is it clear? Any doubts?
See, Vidyashri is saying that tail 2 can be equal to null. But even if the tail 2 is equal to null, then I am not having any worries now because what Abhinav is saying, see, if suppose that some were present and ones were not present. So if after zeros, if we mark it as null, then that will be a wrong case now, because if we update the next, then ones are not present, then we'll after zeros we'll update the linked list as null, which is something that we should refrain from, because if after zeros we mark it as null, then we'll not be able to add the twos that are there, because we'll get a runtime error. Okay, that can happen. But in this case, when Abhinav is saying that for twos you can take it for granted, because even if twos are not present, suppose zeros are there and some ones are also merged into it, after that, even if twos are not there now, then what will happen? Even if twos are not there, then I don't care, because after that I even if I update it
Let
to
me
null,
just let
so
me
what
just
is the
let me just
problem?
explain this thing. Yes, in here also. Okay, let's say that this is our 0 linked list. Okay, and this is our 0. This is our tail z. Okay, and let's say that we don't have any ones, so it's just a dummy node of null, and we don't have any twos also. Okay, these are two things. So I am checking that if our 2 is present, then make our tail z next to 1. And if it is not present, then make our tail z next to 2. This is 1, this is 2. Okay. Now you are saying, what if both are null? So if both are null, in that case also we are at the right place. Why? Because that is what we want. If both are null, that means the tail z is the last node of our resultant linked list, and that should be equal to null. Then also we are right
Uh,
at our place. Getting?
Correct. Correct. And
Yeah.
Vidya, Shri is asking that null pointer exception exists or not. So suppose your current pointer is null, and then you try to go to its next. So its next will not be available. So you'll get an error. So that is
Yeah,
why.
exactly.
Yes, I
Yes.
think you can just summarize the whole thing once again because people are losing track.
Okay, so basically what Abhinav is saying is, basically what we had to do was we had some zeros, we had some ones in the linked list, we had some twos in some random order, and we had to sort the given linked list according to first zeros, then ones, and then twos. First way is count and then make the new linked list according to one by one. You make the nodes and do it. But that's a very brute force approach. Other approach is that you just change the pointers one by one. You make like you have three different nodes. First of all, like you have three different lists, you will have three different lists in which you will be having the head 1, head 2, and head 3, you can say. Like basically first head will be pointing to the zeros, second head will be pointing to the ones, and third head will be pointing to the twos. Now we know that if we like, we'll keep on adding in the zeros, ones, and twos respectively in these three linked lists. But if we keep on adding these things, if we keep on adding them, then what will happen, our head will get adjusted. In that case, we will lose the head of all the three linked lists one by one, and that is not something that we want, because we also want the head of the all three linked lists, and we also want the tail of the three linked lists. So since we want the head of the three linked lists, so we are also taking a tail variable. That is what Abhinav is taking: tail t, tail o, tail 0, tail z, all these stuff he is taking. And then what he is doing in the end is he's trying to add them up. He is trying to append them up. Suppose he had some zeros, some ones, some twos. So what he's saying is, he's saying that he will add the zeros first of all. Like he's already having the zeros. Then for the zeros, at the tail of the zero, he will add the ones, right? That will be nothing but ones dot next will contains the ones. And if it does not exist, then I should directly add the starting of the twos. And even if the starting of the twos is null, then I don't care. But if the starting of the ones is null, if that means if there is no ones, in that case I will care, because suppose if there are some twos existing, then I have already marked the linked list after zeros. I have marked it as null, which is something that I should have not done, because after zeros there should have been twos that should have been coming instead of null. So that is the case that he is also checking, right? I hope that you are clear with this thing. And in this case, he's not taking any extra node. He's just using some pointers to readjust the overall linked list, and then he's connecting them back again. So he's only changing the connections. He's not taking any extra variables. Now for this, there is one more follow-up question that you can do. Like you must have seen, there is a question. Suppose that I give you a linked list in which some even numbers are present and some odd numbers are present. Okay, so if suppose in a linked list there are some even numbers present and some odd numbers present, and I ask you to first of all have all the even numbers, then like suppose I ask you to first of all have all the odd numbers, then all the even numbers, okay, and in the order in which they are occurring in the linked list, then also a similar approach would be followed. Okay, so this is one follow-up question that you can try it out after this stream is over. Okay, it's very similar, but this one is a kind of little bit more tougher than that. It gets accepted.
Yeah.
Again, the time complexity for this will be order of n, I think, Abhinav, and there
Yeah,
is no
it is.
extra space that you are taking.
Yeah, it's order of n.
Okay.
Yeah, so you can also see that
So guys, you can just quickly hit the like button for Abhinav.
thanks guys, thanks. So the time complexity is O of n and the space is just constant O of 1. Okay, because we are not creating a separate linked list, we are just changing the links of the given linked list. Yeah, so that's a very amazing problem, because the first thing which you will get when you will in the interview or something like that, that you can just create another linked list by counting number of zeros, number of ones, number of twos. But this is how also we can do the thing. Okay, great. So should we move forward, guys?
Yes, Abhinav, you can move forward. So guys, you can hit the like button. We cannot see those things. So just, I know that it's 12 o'clock, so that's fine, but we still have 57, 56 minutes left. So all of you can just hit the like button, and just make sure to hit the like if you haven't, and make sure to comment down a +1 as well. Also, Siddharth is waiting. So how many of you are waiting for Siddharth as well? He hasn't solved any problem
Okay,
yet.
so just a sec before moving forward to the next problem. There is a very interesting thing that has been asked. Okay, so I was just waiting for this point of time. So this is a very good question by Tanesh Sharma. It is said that instead of doing 100 things once, do one thing 100 times. So should we apply this approach on DSA also? Should we code same set of questions again instead of increasing quantity? Like, what is your take on this, Yash?
First of all, this quote comes indirectly. It comes from Chandni Chowk to China. Maybe like तुम्हारा एक मूव दूसरे के 100 मूव से भारी होना चाहिए. तुम एक बार अपने मूव की इतनी प्रैक्टिस कर लो. So the thing is, to be honest, the thing is, when you are starting up, it's very important to revise the questions as well. That is for sure. It's very important to revise the algorithms, to revise the concepts. If you are learning, let's say, topo sort, if you are learning, let's say, graph, you are doing BFS, you are doing DFS, you are doing topological sort, you are doing a lot of basic algorithms, Dijkstra algorithm. If you do it for the first time, maybe you do it using set, or you do it using priority queue Dijkstra, but you will not remember it. That is very honest. Even we forget it for now. Like, Siddharth, what do you think? Do you forget sometimes the code, or maybe a little algorithm kind of things?
Yeah, absolutely, absolutely.
We do,
Your
we
take
do,
on
we
this,
do forget.
Abhinav?
So
Okay, so epic, epic expression by Abhinav. Okay, so my take on this would be that it depends on what are you doing on the TSA. Like, suppose I learned about algorithm known as breadth first search. Suppose on the very first Monday I learned about breadth first search or topological sort as Yash told. So what I would be doing is I would be keeping that for future consideration. What do you mean by this? After one day, suppose I learned about it today, I would implement it tomorrow, and I would again implement it after 7 days, and then I would use the regular time frame. But the problem arises that suppose you solved a simple problem, like let's talk about merge to linked list. Suppose you solved it. So what would happen is, yes, revision to that is necessary, but revision to that 100 times is not necessary. In the case of topological sorting, in the case of DFS, BFS, it is necessary. But in the case of the questions, it is not necessary, because we should focus more on quantity in the case of questions. Why? Because suppose I have solved 50 questions 5,000 times, but it might be a scenario which is a very general scenario that the interviewer might not ask it. So in the case of data structures and algorithms, you should be able to master it. To master it, you should be able to do it. You should do it more than 5 to 10 times, even more than 20 times. But in the case of questions, you should master the art of coding, not master the art of mastering a particular question. Because even if you have mastered 100 questions, because what would be the scenario? Because if this was the scenario, then everyone would have mocked up the whole SD sheet given by Geeks for Geeks, and they would be in Google. But that is not the scenario. No? This is not this. So what we can do is, in the case of the DSA, we can implement this. But in the case of questions, we should focus more on quantity, getting out of our comfort zone. Yes, Abhinav, we can move forward.
coming back to the revision part as well, you can use the Google Docs. As we mentioned, for various topics you can use the Google Docs. That will make the revision quite easier. When I assume that when you are saying revision, you are saying that you will write the code again 100 times. That's a lot. Maybe even if you write 2-3 times again same code, it will take a lot of time. So you can have the revision sheet that will help you. Like, you can make your Google Doc of your own, separate Google Docs for various topics or various concepts. That will help you a lot. And you should cover a lot of problems, because as you go forward, if you are doing DSA for 1 2 3 years or something, you should keep on learning new and new questions. You should get exposure to new questions. And also, like, one more thing, you should solve a lot of medium and hard problems, not only easy problems. Abhinav, your take?
Yeah. So yeah, now let's move forward. So let's take a problem. Quick. So then because Siddhartha's take over. Fine. So yeah, let's
Yeah, sure.
move towards the next problem. So I hope that my screen is visible. Fine.
Yes, it is visible.
Fine. So let's take a problem. So problem is something like that we have to convert a binary tree to doubly linked list. So this is a very amazing problem. So the problem is that we are given with a linked list, with a binary tree, okay, and we have to convert it into a doubly linked list, okay. So how we can convert? It is saying that the left and right pointer in the nodes are to be used as previous and next pointer of the doubly linked list. The order of nodes in DLL will be same as the in order of given binary tree. Okay. So now let's discuss this problem, how we can do that. This okay. So let's take example. Okay. Let's take this is the example. This is 1. Then we have left and right subtree. This is 2. Then this is 3. Then this is 4. This is 5. Okay. So let's do this type of thing. Okay. Now what we have to do is that we have to convert this binary tree into a doubly linked list. That is what we have to basically make. Okay. So the thing is how we can do this thing. Fine. So just a minute. Yeah. So what we can do that we will create a doubly linked list where the previous pointer will basically the left node of this particular binary tree, and the next pointer will basically the right subtree of this binary tree. That should be present here. So if I will just take this one as our node of our linked list, so what should be the next pointer of that one? It should be 3, because 3 is only present in the right subtree of this one. And what should be present in the left of it? In the left of it, there is this subtree present. So for this subtree, we will make a simple. So we can raise a doubly linked list. Okay. So for this subtree, we will just take this one. So it will be 2, then 4, and then 5. And now this will be taken somehow here. Getting or not? So it will be something like 5, then 2, then 5, 4 to 5. This is this particular left subtree. Then we will have the node, and then we will have the right subtree. If we will just observe this thing, you can see that this is the in order traversal. This is the in order traversal of the given tree. If you guys knows about the in order traversal, that is what it is. It's the in order traversal of that tree given to us. Okay. Getting or not? Fine. Great. Now the thing which we have to do is like that. Like we will have these type of things. Now the thing is how we can find the in order traversal. So if in order traversal, what we have is, first we will have left subtree, then we will have the root node, and then we will have the right subtree. If you will just make a perpendicular line on all the nodes, and then if you will just iterate like this, just move like this, then you can see the first node which we have encountered was 4, then 2, then 5, then 1, then 3. Okay, this is the case. So in this case, you can see that is also what we are doing here. Getting or not? This is what is given here also. It is 4, 2, 5, 1, 3. It is basically the in order traversal of this binary tree. Getting or not? I think that to understand this problem, it's better to first to understand this problem, it's better to first we have to just code it, and while the implementation part, we will understand more clearly how the question is like. Okay, great. Now the thing is that what we will do here, this is the problem. Okay, let's make it full screen. Okay, and then we will just solve the problem. Fine. So first of all, what we will try to do is that we will make a check on the root node. That is the very base condition. So the base condition will be that if our head is equal to null. Is this clear, Siddharth? This logic was clear now? How I was just doing these things? The in-order traversal thing?
Yeah,
Okay, fine. I hope that if there will be any doubt in the audience, you will just tell me now. Sure.
yeah, sure.
Okay. Yeah. So this is the base condition. That if our root, here we have a root now, not the head. So we can make it like root. Okay. Then the next thing is that, as I told you, that in order traversal, what we have to do is we have to first take the left subtree, then we have to take the root, and then we have to take the right subtree. Okay. So what we will have here is that we will make some check. Okay. So we will have 2 pointers. First is the head and second is the tail. Because why the head and tail will be required? Because obviously we have to, for a root, we have to make the root next is equal to right subtree, but we have to also make the root previous is equal to the left subtree, because this is a doubly linked list. To make this check, we have to also take a tail pointer. Okay, so it will be like node head, that will be equal to root. This head will basically or we can write it currently null. Let's make it null.
Abhinav,
Yeah.
Abhinav, sorry to interrupt you. Can you
Yeah.
increase the font size?
Yeah, sorry for that. I just
Yeah, absolutely.
I hope it is okay. Yeah, fine.
Yeah, it's
Okay.
absolutely fine. Thank you.
So it's null. Fine, guys. Now the thing is that we have to convert. So I think that for this, let's create another function. Okay, that will be better. Otherwise, it will be very complex. So let's make another function. Let's name it binary 2 DLL. Okay, and in that function, what we will have is we will have the root node, obviously, let's say the root node. So we will have the root node. Okay, and along with this root node, because we have to convert this binary tree into a doubly linked list, we will have the head and the tail node of a doubly linked list. So this head and tail are basically the nodes of a doubly linked list. So we will have that too also here, and we will take the reference of that, so that the changes which are basically done in that particular function should be reflected here. That's a very good concept. I hope you all know, okay, of the reference. Fine, great. Now we will just call this function here simply. Okay, so we can just write it like root, and then because we have to give the reference, so we can write it like head and tail. Fine, guys. This is how we can do. Now thing is that now let's write this function which is binary to DLL. Again, the thing will be, because we will make it a recursive function, because to find the left subtree and the right subtree, we have to make recursive calls. Okay, so the first will be for the left subtree. So for left subtree, we will simply call this function. Let's copy it from here. We will just simply call this function again, but this time don't give the reference here, but this time for the left subtree of this root node. That is what we will do. Similarly, we will do it is for right subtree too. We'll do the same thing. Let's copy this, just like what we do in finding the in-order traversal. Okay, and between that we have to take use of our root. That's the main thing which we have to do. So because we have given here our head is equal to null, so we have to make a condition that if our head will be equal to null, then what we will do, let's take the reference of it. Okay, fine. So if our head is equal to null, then we will make our head is equal to the root. Fine. That's the first condition from where we have to start. Otherwise, the another two conditions are here. Now, guys, we have a root, okay, and we have a tail. We have to update the value of both the things. Okay. So, guys, the thing is that if I will just again explain you the thing. This is our root, okay, and there are two subtrees, the left and the right. Okay. So you can just observe one thing. What we have done currently, what we have done, if I will just remove all the other things and I will just, okay, let's create another path, another graph for better understanding.
Yeah,
This is a
Abhinav.
one. Yes.
Abhinav, sorry for interruption. You can just, when you are summarizing it once again, please go a little bit slow. Okay, this is
Fine,
a hard
fine.
level
Yeah.
problem, so we can expect people to understand it by giving them
Sure.
a little bit
Also,
clear
Abhinav,
deletions.
can you draw a tree for me? Like 2 is connected to 4 and 5. Now you connect 3 to, let's say, 6 and 7?
Sure, sure, sure. Sure, we can do that like that.
Uh, okay.
Okay, fine.
Okay. Okay.
So yeah,
Now, if I have not understood it wrongly, tell me if I'm wrong, Abhinav. You are asking me in this question to first of all have all the leaf nodes collected and make a doubly linked list out of it. Correct? That is what I'm thinking of.
no, no, that's not the thing. What I am saying that we have to just take that root node, okay. But the thing is, we have to take a node, okay, let's say one, and we have to convert in doubly linked list. The property is that the next node of this doubly linked list should point towards the left to the right subtree of this one, and the previous node should point towards the left subtree. Getting or not?
Okay.
Okay. So what I will do,
Mm,
that currently what I've written here, you can see here,
okay.
I have written that head is equal to node root. So currently our head is something here. This is our head. And what we want that our, and we are also having a pointed tail. Okay, we are also having a pointed tail. So let's say this is our head. And we want a tail, something you can say before the head. Okay, something here. So what does that tail should be? This
Uh,
particular should
can
point
you take a
towards
smaller
here.
example for me, let's say?
Yeah,
Can you
we
take,
can just
let's say, 1, 2, 1 is connected to 2 and 3. Can you take that? You just keep
yeah.
this example also. Keep this example. Okay, let's take
Let's
this.
solve this. Okay, it will be better. Okay, yeah. Okay, is it okay?
Yeah. Can you
Fine,
explain me
fine.
what we have to do now again?
Yeah, sure. So what we'll do is that we have to just convert this thing, this binary tree into a linked list. The thing is, the property is that this is the root node. We have to make this root node, and the next pointer of the root node should be equal to the right subtree, which is 3, and the left pointer should be equal to the left subtree, which is 3.
Let's say if we now don't talk about subtree, so it should be equal to the next node that I see in the traversal, right? It should be equal to the right guy.
Exactly, exactly, exactly. Yeah. Is it clear now?
And you are saying that you will make a doubly linked list out of it. Like, let's say 1 is the center, right? 1 is there. So towards the right of 1, there is a 3. So I'll attach a 3 to it. Towards the left of 1, there is a 2. So I'll attach a 2 towards its left. And since it should be
Exactly,
doubly linked list, so you are saying that you will create a doubly linked list property as well.
exactly, exactly. Yeah.
Okay. And if
Fine.
I'll be honest, so if I see the order in which you have taken, so I can see 2 is taken first, then 1 is taken, then 3 is taken. So can I
Yeah.
say it's left root and then right? And in that case, what I can think of it as in order?
Yeah, exactly. That is what we are just discussing in the start also. That this is the in-order traversal of our binary. I have discussed that. Yeah, it is the in-order
Basically, I have to
traversal.
get the in order traversal of the binary tree, and then I have to convert that in order traversal into a doubly linked list. Can I say that?
Yeah,
Is that
exactly.
the
That is
thing?
what we are doing. Yeah, exactly. So basically, in-order traversal, what we do that we first focus on left subtree, then our root node, then the right subtree. That is what we do now.
So, so are you doing it like this? You are first of all taking out the in order traversal, then you are making the linked list out of the array
No,
that
no,
you
no.
have
That is
got.
not what we are doing. We are just first calling because of the left subtree and the right subtree, and between them, we are using this root node to construct our
Okay.
doubly linked list. Yeah. So what we
So
will do
is this
now?
much part? Is the question clear to the audience? Because some people will not clear with it. That is why I'm asking this on behalf of the audience.
Yeah,
So
sure,
now, are
sure,
you
sure.
pretty much more clear with it? At least, all of you can write a yes in the chat, or if there's something that you are still stuck at, you can still tell us. We are waiting for your comments in the chat. So if you are still stuck at something, because this is a kind of hard question. So if you are stuck at something, if there's something that is bothering, So you can tell us. Tanay is saying that can the root node of the tree be the head? I don't think so, Abhinav. What do you think?
How can root
Root
be
node
head?
cannot be
No,
head.
it will not be the head. That is why I am taking a tail too. Na? I am taking a tail too. A tail is also here.
Okay.
So that tail will basically make check on the left subtree. So whatever will be the root left, we will make it to tail. Now the
Okay,
root
Abhinav. So
left is
whatever.
the tail.
Okay, so whatever you are doing, can you do it for us on this example? Can you do a dry run for this for us on this
Sure,
example? Let's say.
sure. Yeah, sure. So let's see. Let's just
You
erase
can draw
this
it
thing.
again if you want. Yeah,
Yeah,
now
sure.
it's
Fine. So now, guys, let's see that what we have. Okay. So this is a root node. This is a root node. Okay.
so
Now what
from
we are
here you
doing?
are starting with an in-order traversal.
Yes, from root node only. So what I'm doing?
So from
That
here you are
first,
first of all going to the left. Okay.
yeah, exactly. So first I am recursively calling for the left subtree. Okay.
Mm-hmm.
So left subtree will be something like here. Just a minute, guys. Yeah. So left subtree will be something like here. This two. So that will be the call. Let's say the binary to DLL. That was the function, and let's make it left subtree. That was a call I've made. Then I have a root. Then I have root. Now this is
So
something what
what you are
I'm doing.
doing when let's say you call for the left, so you go to 2. Then what you will do? Tell me that. Let's say you call for the left. We all
Okay.
understand that you are going to the
Okay.
left. Then you go to 2.
Fine.
Then you're currently you are pointing to 2. Then what will you do?
Fine. So okay. So this is our. So for now this is our root because we have just basically
Uh,
gone to the left subtree. Fine.
Correct.
So now I
Okay.
will just check for the. I will just check for the again the left subtree of this root. But that is not present. That is null. That is null. Na? So if the left subtree of a root is null, that means that will be the tail node of our linked list because that will be the first. Because you can see in the in-order traversal, the leftmost node is our tail node. The leftmost node is the first node of our double linked list. I hope this is clear. If we are going on a in-order traversal, so in-order traversal starts from the leftmost node and ends on the rightmost node. So if we have got a leftmost node of our binary tree, that will be the first node of our linked list. Is it clear? Yes.
Okay. So what will you do with this?
For example, I'm just like saying like this. If this is our tree, let's make a big tree. Okay. So this is the leftmost node of our binary tree, and that will also be the
So
first
if
node of
I'm
our
not
linked
wrong,
list.
what you are doing is first first of all you are at 1. You started from 1, so you can put a red pointer there.
Yeah.
For us.
Yeah.
So you
Yeah.
were at 1. Okay. Then from that you you went to the left, so you went to 2 from there.
Two.
Correct.
Exactly.
Then
Yeah.
then 2 is the current root. So then now for this 2 you went to its left. Correct.
Yeah. It is 4. Yeah.
Okay. Now what are you doing?
Now again
That is
I'm
how
checking
you reach
for
the
its left.
leftmost node. Okay.
Yeah. Now again I'm checking for the left node, but it is not present.
So now
The
you go
left
to
is
its
not
left.
present.
It's not present.
So
Okay.
now I will make it to the tail node. That this is our tail node. We have got a tail node. That's the first node of our doubly linked list. That's the
So
first node of our doubly
can
linked
you
list.
write it on the top right corner for us? That okay? The tail is 4 now.
Yeah. So our tail is currently 4.
Okay.
Fine.
Then you will then this recursive call will be done.
Yeah. This will be no.
Now
Now it will be done. Yeah. Now it will be done.
no. Then after this, you first of all processed for 4. You process its left, so its left was null. So you came back from there. Then 4. That currently you are doing the in order. So you went to the left. Left is null. Now you are at the
Now I had
4.
2. I
So
had 2.
4 you have processed. No, 4 you were at 4. Then you went to the right also, na 4 4. But for its right is not existing. So
Yeah.
all the
Its
calls
side
are
is also
done.
done.
Now you will backtrack. Now you'll move back. Right?
Yeah.
You can
Now
write
we
an
are at
arrow up.
2.
From 4 you are moving up to 2 again.
Yeah.
Okay.
Now we are at 2. Okay. Great.
Okay.
Fine.
Then when you are at 2, then what are you doing?
Now again, so now because I have moved to the left subtree, now I will check for right subtree of this 2. The right subtree of this 2. Okay. So this is the right subtree, which is 5. Now for this 5 also, what I will do, I will check the thing, getting or not. Means if it's
Okay,
left
so
present or not.
you have kept 2 on the hold. Like you have not done anything with 2 up till now.
Yeah, so just a 1 minute, just a 1 minute. The thing is, yeah, that the thing is that now our two will be our tail. Now two will be our tail. Getting on, because when we are backtracking, now two will be our tail. Getting or not?
Okay, so
Currently our
so
tail was
after that
here.
you'll add 2.
Yeah. So now I will add 2 to here. So currently it was 4. Now I will add 2. And then I will check for a right side of 2. Because the right side is present, I will implement 5 here. Now this will be here. This is how I will just move onwards. Getting. So now
So
this
this,
is.
okay. So basically, if I see your approach as much as I can see now, so you are how are you making the doubly linked list as well? Can you tell us a little bit more about? See, I can see that towards the for one towards its left, there is a 4 present, there is a 2 present, there is a 5 present, and you have
Yeah,
made a doubly linked list out of it because you first went to the left, then you process the root, then you process the right. So 4, 2, and
exactly.
5 you were able to make in the doubly linked list, and I can see that the
Exactly.
left part now seems to be in a form of a doubly linked list. But can you tell us a
Exactly.
little bit more how you have made it, like how you went back and forth in the connections as well, so that it is more clear to us? Like for
Yeah,
4, it
sure.
is it's
So let's take let's zoom this thing. Okay, and let's take the for this 2, 4, and 5 only. Can we do that? 2, 4,
yes.
and 5. Okay. So let's see that. Let's take that we are at here. Let's say our route was here. Then we move towards the. So there were 3 calls. The first call was for the route left. The second
Okay.
for the route, and third for the route right. The 3 calls were there. Okay. Now for the route, first
Basically,
process
2
this
calls
call.
were there. The for the left and the right, they were calls,
Sorry,
and
2
for the
calls.
route, you were
And
processed.
yeah. So when we are at route left, what we will do, we will first check its left part. If that left part is not null, getting or not? If its left part is not null, then we will make its right is equal to the root node. Just see it, okay? Just see it. What I'm saying, just erase it. Just erase it.
So for 4, you are saying for 4, you suppose you're currently your route is standing at 4.
Yeah.
Then you're saying that if its left is not null, but I can see its left is null. Then what should I do?
Yeah.
Its left
So
is null.
if it's yeah, exactly. If its left is null, or if its left is not null, so just a thing, guys. Okay, just the thing. Okay, मैं एक काम करता हूँ. Just make a tail here. Okay, this is our tail. Currently it is null. Currently it is null, which is the initial case, which we are taking at from the start. Okay. Now what I will do, I will make our root left is equal to tail. Can we do that? And let's say our root is here. Let's say a root is here, because we are taking a root now. So in that operation, when we are going to root left, our root left is tail. So currently this pointer, which is null, is our tail. Getting? So यहाँ पर हमने अपनी tail, this is our tail. Root left is equal to tail. Fine. Now, if this tail is not equal to null, if this tail is not equal to null, then we will make this tail right is equal to root. Okay. And then the tail is equal to root. Getting? So this tail, the tail's right will be equal to the root, and this tail will be equal to root at the last. So after doing that complete thing, what we are doing is we are processing that we have this 4 and we have this 2. So this 2 is its left is tail, this is tail, and its right should be the right, its next should be the right of this root, which is 5. This is how we have to do. Getting? It's quite it's a little bit of a hard problem. Okay, I was just thinking to take a hard problem in the so that is why I've just taken this. Okay.
Okay.
Yeah.
So you have built this, let's say.
Yeah. So
So
this is how we can just create, and after building this for these 2 things, we will also create the same thing for this particular subtree, which will be 6, 3, and 7, and then just assuming these two as separate, we can make it like 4, 2, 5, then 1, and then this whole thing. This is how our answer will look like. Okay. So maybe when I will just write the code and you will understand it more.
Okay.
Okay, fine. So let's do this thing. So yeah, so what we will do is, so first, if the head is null, if there's nothing in the head, then we will just simply make it true. Okay, and there I have basically made two recursive calls for the left and right subtree. Okay, so what n type of confusion. Now here we will use the root to make our particular thing, our particular calls. Okay, now I will make its root left is equal to tail. So because we were taking reference, I will write star tail. That's the reference. Okay. Now, if our tail is not equal to null, then we will make our tail. This is the exact point where you have to just focus on. Our tail right will be equal to root. So our root net is equal to tail, and if our tail is not equal to null, then we are making tail right is equal to root. Okay. So because maybe you are confusing that we are just creating a separate W linked list, but again we are not creating a separate W linked list. We are just changing that binary tree into a W linked list. That's the thing now. So we don't have to create the other nodes. We have to just change the links between that. That's the exact thing which we have to do now. So maybe that's basically a reason why you are not getting it. Okay. So it's like tail, it will be equal to root. So this is how the whole thing is going on. So first we will make a root left is equal to tail. So our root left will be equal to the tail. And what we are storing the tail? In tail, we are storing the last node, the tail node. And if tail is not equal to null, then tail's right will be equal to root. Getting or not? So what I am saying is we are just converting this given binary tree into a W linked list. We are not creating a separate W linked list. We are just converting it into a W linked list. So what we will do is that if we are doing it for this 2, 1, 3, let's say, if we are doing this for this particular current node. So for this root, when we will recursively call for this root, its root left will be equal to tail. Why? Because our tail will be something out here. So when we recursively call for that root, so the last root in the in-order traversal will be our tail. That's the exact logic. Getting? So then what we will do? If it present, we will make the, so here we are doing, what we are doing here is that we are making tail right is equal to root, because that is what we have. This pointer we have, the pointer which is pointing from root to the left node, but we are not having this pointer, this which is I have made it from blue. That is what we have to add. Getting or not? वो pointer हमारे पास है, that pointer which is pointing from root to tail, but the pointer which is pointing from tail to root, that is what we don't have, and that is what we are making here, that tail right is equal to root. So we are not creating a separate doubly linked list. We are just changing the links and the nodes of the given binary tree so that it can be converted to doubly linked list. That's the logic, and that is why it's quite confusing to understand. And similarly for here also, for here, when this will be the root, this will be the tail. Tail is basically the last node we are making check when we are having the in-order traversal. So you can see that we are having a check, but this node is not present. So these type of things we can do, and we're just converting it. If now you will just see here, also I think that we have to just tail is not equal to null. Listen, what we are doing now, if our tail is not equal to null, the thing is, just like we are making a check here, similarly we are making check here also, because initially we have make our tail is equal to null. So to avoid that initial values of tail, we are doing this thing to avoid those initial values. Okay, so this is what we are doing. Fine. Now after this, we have to just return the value of our head. Let's compile it. There is some. Okay, so here it should be return, I think. Okay, so here we don't have any return. So there will be a base case also. The base case will be that if our root is equal to null. Okay, that is our base case. That if our root is equal to null, then we have to just return. So that's the condition. So it's at the line number 145. Okay. So here we have to make return root. Sorry. So yeah, it is right. Let's submit it. Yeah. So yeah, we have got this right answer. Okay, this is how we are just doing this. So it's something like the combination of in-order traversal and doubly linked list. The thing is that we are basically focusing about the most optimal solution, how we are not using extra space. So yeah, that was something that that this problem was also related to binary tree. So maybe it was not considered to take it today because that was not a thing of binary. But I was just wondering to take a problem of doubly linked list. So I just thought of to take this problem because that is also a very standard problem. You can see there are 100k plus submissions here. And if we just take out the company tag, it is asked in Amazon, Microsoft, Goldman Sachs, Morgan Stanley, Salesforce, all the big companies. So that is all just thing to take this question. Okay, fine. So I hope that now it is clear. I know that it was quite confusing. It was quite hard because it is a hard problem. Okay, but it is type that we can just do that. Okay, yeah, fine.
I think Siddharth, you can take the lead from here.
Yeah, sure. Okay, fair enough. So now, as the time frame remaining is 17 minutes, and I don't think we should move forward to any questions which should be completed half. So, till this point, for the next 18 minutes, this is a Q&A session. So quickly raise your doubts in the comment section. We will try to resolve your doubts as much as we can. Okay.
We
So
will be taking
resume
we'll be
review,
taking
resume review session would be done explicitly on a different stream. Okay. So हिंदी में हो तो माहौल बन जाना क्वेश्चन करने में. Okay, sure, but many people are there from Andhra Pradesh, from Tamil Nadu. So what I try to do is Yash and Abhinav are more inclined towards English, but as I belong from Jharkhand, so what I try to do is I try to sum up the whole question in Hindi so that the people from these places could understand it much better.
this is
And माहौल तो बन
Siddharth
ही
can
जाता है.
even do it in Bengal. See, even Siddharth can even do it in Bengali.
हाँ,
We
अभी
are
बांग्ला तो पढ़ देते पढ़े.
he can even do it in Bengali.
Okay, when is your next live video will be coming? The next live video, the next live video would be there in the next week or so. Okay, but it's still not confirmed. Okay, so it would be mostly on the weekends. Okay, two good session. Kudos to you three. Thanks a lot, Vanshika. Okay, thank you for it. Means your efforts will help us. Will not go in vain. Cheers. Thanks a lot, man. All the best to you. Me too from Jharkhand. Hi, I'm also from Jharkhand. Okay, nice. Thanks for your time. It was great. Thanks. Okay, so not so these all thanks given can be done in the comments, which would in return increase the reach of the video and it would help us more. So you can just
Uh,
ask your questions here, and Thanksgiving can be done in the comments. It would help us more. What do you think, Yash?
Definitely. And one more thing, if you think that this was useful for you and for your core group of friends, let's say the people whom you are doing BTech, or with whom you are studying, with whom you are doing pair programming or something, so you can share it with them as well. Okay, like the biggest thanks for us will be if you can share it or if you can like it, right? That will be really great. And Amazon
Okay.
Play Vessel.
How to be consistent. Let's tell this. So what I try to do is there was a time when I started with this internship. So there was a time there were two times when this happened. Like the first time when I started off coding, I was not getting consistent because I was initially accepting failures. I was not able to accept failures, so it was a difficult point of time. So at that instant, what I used to do is I used to maintain a Google Sheet where I used to make a box green. Okay, like suppose today I was able to do coding, so I just made it green. The next day I'm not able to do it, I left it. So it is just like the GitHub graph, and every day I solve questions, I do this. So this kind of helps, so acts as a motivation to make everything green. What did you do, Yash? What about you?
Regarding this thing, regarding failures.
Yeah.
I still like we still face failures if to be really honest. But it's just that if you are not able to solve a particular problem and you are considering it as failure, then you should not do it, because if you have done a little bit of CP, or let's say even DSA, then if you are not getting something, let's say if Abhinav was solving this problem, so it's not that Abhinav solved it in the very first go. He must have solved it almost maybe if I was there in his place, then I would have solved this problem for 1 week, or let's say 3 or 4 days, right? So that is the
Okay.
thing. You should not get demotivated.
Okay, so
uh,
there is a very so talking about this failure thing. This failure does help a lot in two scenarios that I have observed. In the case of going to the gym, hitting the gym, and as well as in coding. Suppose you don't know a particular question, then the only outcome of that would be that you would learn a new idea. Okay, and training with failure would also solve the same purpose. It would help to the growth of your muscles. Next, how to balance learning and practicing DSA. It's absolutely very easy. Like if you solve questions the whole day, it would be fun, but after a certain point of time, after 1 or 2 months, it would get boring. Like I'm just getting questions, I'm trying to solve each one of them. So what you can do is you can just learn in the first hours of your day. Like in the very first hours, your mind is fresh and you can take new inputs. And for the rest of the day, you can keep on solving questions. What's your take, Abhinav, on this?
Yeah, exactly. Means the thing is that DSA is something a thing to practice only, according to me. And if you are just learning while practicing, that's a good thing. Means people say that you are practicing while learning. I don't think that's the correct approach. You have to learn while practicing. Practice is the most important thing in DSA. For let's take example of maths. In maths, what we do, 90% part in maths, what practicing. You are just practicing problems, and while practicing, you learn new concepts. The similar is the essay also. You have to practice, and while practicing, you get new concepts that you have to learn. That's the thing.
Ami Bhaloachi, what about you? I think I would be the only one who would be able to reply to this. Okay. So, any specific topics on Amazon SD off campus? As far as I've seen, the next question, the current one was the first question was from prefix sum, and the second question was the easy one. Talking about the next is recursion. Okay, people are suggesting recursion. How much time it is taking to be a good programmer? It entirely depends upon the definition of good you have. For some people, so for some person, being like me is good, but for me, being like Yash might be good. Okay, so for everyone, the definition of good or better or best is different. So recursion से कैसे deal करें भैया? So what I think is, don't see the code of recursion. Just don't see the code of recursion and copy it blindly. Please try to draw the recursion tree as much as possible. That would be my only suggestion to you. Any suggestions from your side, Yash?
Regarding recursion, I'll suggest that you
Yeah.
can select the topic recursion on Geeks for Geeks practice. You can directly go to practice.geeksforgeeks.org. Then you can select the topic recursion, and you can select some companies in which you are wanting to go, and then you can select the easy tag for the recursion topic, and you can solve a lot of problems based on recursion. That will not only give you a confidence in recursion, but you will also see a lot of easy problems you will be solving based on companies as well. So that will there will be two advantages of this. First of all, you'll be solving a lot of easy problems based on recursion that will enhance your knowledge. Apart from this, the second thing will be that you'll be solving a lot of company problems. So you'll be getting an idea how the companies are asking the recursion questions as well. And also, as we know, recursion will be used in DP, it will be used in binary trees and segment trees and everything. So that is also one added advantage.
Sure. The
Uh,
next question is how a newbie can solve different problems from here. And it is also told how to build logic of programming in mind. So see, you shouldn't consider this as the very first goal if you are a newbie. The very first goal should be that you should be able to bring out the summary of the question in pen and paper. Like whenever we as mentors, whenever our students are not able to understand a particular solution, we suggest them to do the dry run on a pen and paper. The importance of doing the dry run or importance of thinking using a pen and paper is very underrated according to me. It should be focused way more in the first place. What do you think, Yash?
Same thing. I like completely agree to your point. Like, there's nothing much that can be added on it.
Okay. Okay, this is a continuation. তুমি কোন কলেজে পড়তে? This means that which college I used to study. Brother, I have still not graduated. Okay, so Yash, for me,
Uh,
your speed of talking is a little fast. Okay, the very common concern you have. Abhinav accent is difficult to grasp. Okay, fair enough. Abhinav wouldn't be.
but
Siddhartha,
he
okay.
looks very professional, to be honest. Like his way of
Who?
No,
talking seems to be very
I also
professional.
have to just slow down my speed. Means I have to just down my speed. That I will do,
Uh,
and maybe that will just make my essence
Vidyashri,
better.
I take your feedback. I take your feedback. But the thing was that I had brought 6 questions, so it was like I had to be a little bit speedy. Otherwise, other people would have not gone. Like, we wanted to expose you to as many problems as possible. That is why I
Okay,
tried to be a
so
little bit
that
fast.
is entirely Yash making an excuse. I don't think you would be able to find a video of Yash where Yash is speaking slow. I don't think. So Yash is अभी
Um,
okay अभी वर्क फ्रॉम होम है मेरे लिए इजी है अगर वर्क फ्रॉम ऑफिस हो गया तब लर्निंग नहीं हो पाएगी दैट इज एब्सोल्युटली नॉट द सिनेरियो. Okay, some point of time, everyone, we and Yash or Abhinav, some point of time we are doing our streams at the home. Some point of time we are doing our streams in the college hostels and all. Okay, it entirely depends. It entirely depends on your motive. Okay, you need to prioritize your things. Okay, so if we can do it, you can also do it. We are same person. Sir, I can even okay. Abhinav, what do you think should be the solution of this?
Sir, I can understand question easily, approach easily, even this one hard question easily. But sir, there is problem writing the code. Can you suggest what I do? Okay. So for writing the code for implementation, what I have just observed that uh, the the basics, the clearance of the basics is very important. For example, that if you don't know how to traverse a linked list, then you cannot write a program of reverse a linked list. If you don't know how you can reverse a linked list, you cannot write a program of how you can find a palindrome in a linked list. They all are just attached. We have learned traversing. Using traversing, we have reversed. Using reverse, we have found the palindrome. That is what we have discussed in the first 3 questions we have discussed. This is the thing. If you want to implement a better level question, a hard level question, you have to first make your basics clear. At least if you are able to solve a good level question, a medium easy level question, then surely then you have to just step towards the form. So just my advice is that practice more and more basic questions if you can, and that will basically help you to grab a good better question. Okay.
So, how to approach brute force method? Brute force method is not something to be approached. doing what is said is most of the time brute force approach. Okay, so you don't need to freak out on this. So tips to convert DP recursive to DP iterative. Okay, so what you can do is you can watch either of our videos of Yash, Abhinav, or mine. Okay, and you can see how do we convert from deep memorization to the DP iterative. Okay, your views on coding contest. Yeah, yes, you would like to add anything?
Another thing on this, let's say the best thing is that if you don't want, let's say you don't want to watch videos or you want to cover many problems, in that case you can go to GeeksforGeeks.org website where the editorials are there for every problem, like where you have like the complete solution written. So first of all, you'll see they will usually write a solution in recursive DP and then they will memorize it. So you can see the pattern, like how they are seeing that okay, in recursion whatever is the base condition, that is the same basic condition in like if you see in Fibonacci. So if f is equal to, if let's say n is equal to 1 or n is equal to n is equal to 2 is the base case, so that is how they will also write it in terms of uh, iterative code. So these things, if you will look at the code more and more, then you will be more confident with iterative DP.
Yeah.
Okay. Is it necessary? Okay. So is it necessary to be good in DSA to be good in competitive programming? Absolutely no. I don't think any further thing is necessary. Okay.
If you will see
It's
linked list,
absolutely not.
if you will think see linked list is not asked in competitive programming, binary tree, binary search tree, a lot of things are not asked, so it's absolutely not necessary. But you should have a basic understanding. Like if you have basic understanding, then you can start with code forces and another website, that will be great. uh, Someone is
Absolutely.
asking how to crack Amazon. So I think that you have not checked out the channel, that is Geeks for Geeks Practice Properly. On this, we have one person from Google, that is Soham Mukherjee. So he has taken the Amazon in 29 days series. So there he has solved almost 58 or 60 problems. So you can go to the playlist, that is Amazon in 29 days, on this particular channel itself. And from there, you can, if you want, you can watch that series as well. Other than this, if you want to go for something very precise and paid, then GFG also has something that is known as Amazon Test Series. So in that they have curated questions and test series contest for Amazon. So you can also go for that. Correct, Siddharth?
Yeah, absolutely correct. So, how many questions is enough for cracking Amazon? So, the amount of questions, let's suppose you are preparing for your maths exam. So, does the amount of questions you have solved in your for your maths exam depends on the amount of numbers you would get? No, it is not the scenario. The scenario is such: how many different questions have you done? How many questions out of your comfort zone have you done? And how many learnings you were able to get from the questions that you have solved? Okay. What to do apart from DSA to grab a good job opportunity? Obviously, development. Anything more you would like to add, Yash?
I think object-oriented design, object-oriented programming. Sorry,
Core
object-oriented
subjects.
programming. Code, not exactly code. Like not every subject is required, but at least DBMS is required. At least you can say object-oriented programming and operating system. These three subjects should be there. Apart from this, SQL also you should know. Computer networks is not that necessary. You can go for the top 50, 100 questions for that.
Okay, so the last question is that which college you are in? Abhinav, you are in which college?
Yeah,
The
I am
same college
from
from which physics wala is there.
yeah.
Hmm?
So please follow as my alumni. I am from Adcode Butler Technical University.
And the thing,
Yash?
and he's from my school. He's from my school.
Huh, same. You knew him before?
that
Yash?
that I don't know. That I don't know.
Okay.
Yeah, he's from
Okay.
Allahabad, na? He is from my school, and he's from his college.
Okay. And Yash, you are in which college? People are asking.
Madan Mohan Malvi, University of Technology, Gorakhpur.
Okay. Okay. So ad hoc problem and constructive problem solving. This bothered a lot in code process. What is your take on this, Abhinav?
Uh,
Yeah, because you have been doing a lot of CP, so people want an idea about it from.
yeah, but you guys also have much experience on CP, so you all can also just answer this. But yeah, obviously, in CP, whatever I have just observed is practice, 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 practice. I will just say it 100 times, 1,000 times. Practice is the only thing. Practice is the only thing which will make you master CP.
Okay, see, currently suppose you are at 1,000 rating in code courses. So you should try to solve the problems 1100 or 1200. Okay, and what is the tip from my side to solve ad hoc or constructive problem solving? The basic tip that would be there is that if you talk about code forces, if you talk about at code amount, many constructive or ad hoc problems are based upon a property, like a property of number system, many a times. So you should not forget it. Okay, these are some exceptions. Like you should write it in a doc, or you try to learn the usage of OEIS, where you can paste a pattern and you can find out the answer to them. Okay, try to use that. Try to learn using that. The next one, the most important tip is try to do the dry run on your pen and paper. Learn to make learn okay let's yeah. So learn to make anti-test cases and others. Okay, as a newbie, the tips to make coding club in college. So the tier and all doesn't matter, to be honest. I'm from a tier 3. I don't even have a coding club in my college. That's absolutely not necessary. You do your job, you be an inspiration to others. And if the luck favors, it might be a scenario that you would be the founding member. But as of now, don't try to become a founding member or don't try to make a member until you become eligible to as a leader. Okay, try to be as a leader. Okay, this is question is from me. Okay, I study in Netaji Subhash Engineering College in Kolkata. Okay, thanks a lot, Kumar Gaurav. The core areas for cracking college placement. The core areas are prefix sum, sorting, binary search, these all things. What do you think, Yash?
Uh, what is the question? Can you
Code areas for
can,
cracking college placements. It is asking.
so basically you should be good in DSA, and you should do a little bit of competitive programming, or maybe weekly interview series that is there on Geeks for Geeks. You can do that for covering the coding rounds and the interviews. Then after that, you should at least read the top 50 100 questions on every core fundamental CS topic that is there. And apart from this, one or two projects will do the job.
Okay, quickly
Core
like the
areas, for
video.
core areas, if you but if for core areas, if you want to do well, so in that case, what you can do is you can go to Geeks for Geeks and you can learn about like if you'll see on Geeks for Geeks, it's very given in every topic for core fundamentals is given in a structured manner, so you can check out that.
Okay,
uh,
so Sachit is absolutely going crazy to know we are in on which team on games. Okay. Okay, so I have so only I have the dual internship. Rest Yash and Abhinav are from the mentors team. I am also from the SDE team. Okay, so yes, Sachit, we have heard it. Rohit Paul, which language is more important these days? I'm doing coding practice in CPP, but my suggesting other language. So you're already doing practice in CPP, and it is the most favorable according to the most number of people. So I think you should move forward with that. Okay, okay, that's it for today. For the last 1 minute, so there might have been so the same goes for this time also. There might have been an instance that we were not able to resolve someone doubts, but at the end we are just a human. Okay, we might make mistakes. We might do some other stuffs. It might be a scenario. Someone would be low, someone would be high, and you need to accept the fact that we as a human can't be on the same graph every time. So that's it for
uh,
today. Yeah,
and also one
anything
more
would
thing, like this is something new that we are doing, right? We are doing pair programming, or programming in some terms of triplets, right? Tuples. So this is very different concept, so you can let us know after this video is over. You can comment down what are your views, what do you think, and if you think again that it is good, like if you think that we are doing something that is worth your time, make sure to share it with your friends and like the video as well if you haven't. And Siddharth, now you can take the lead.
Yeah. So just as Yash told, just adding some more to it. See, we are also learning at this point of time. Like by teaching you, we are also learning how to manage this, how to manage that. So we are also making mistakes. Okay. So we also make mistakes, and you are also making mistakes, and that what's make us human, not robots. So that's it. I think that's it for
Yeah,
today.
sure.
Thank you and have a nice day. If you are watching this after the live, make sure you leave a comment so that the reach of this video could be increased. Thank you, everyone.
Thank you. Thank you, guys.
Bye,
Thank you very
everyone.
much.